First thing I want to announce is that, aqua aerobic people are gonna join us at 4. So all these questions you have in the back of your mind, we'll have some time to ask them, and I hope you have questions. If you don't,
Listen,
no. I have a few, but not a whole lot.
My question is, they've got magic dust and
they're not sharing it.
and I don't know what it is or how they get it, and I saw their cutaways of their little modules and things like that. And I'm still a little perplexed how do they make it out of normal slide? And why doesn't somebody else go climb over the wall of their thing and steal some of it and take it to every other plant in the world?
Well, that's a good question to ask them.
I don't know.
Yeah,
I mean, it's
I gather it has to do with the selective wasting of the sludge. They get rid of the little guys and they let the big guys grow.
And I was gonna say, and Barbara and I connected with Aqua Narita, and we kind of took the questions and the conversations from the last time we met, even though you couldn't hear me, I was texting Sharon, and we kind of vomited them onto to Aqua Narita to let them know, some of the things that, do we dare use the word disappointed in, but when the presentation was taking place and unfolding, just not so much like a disconnect on what the expectation was versus what we received. It was more on the sales side instead of like generally talking about, we have all these different areas within the plant that could potentially be reused. I mean, that was one of the hot topics that we brought up, is that it seems like they're taking the existing site and trying to focus in on building new infrastructure instead of utilizing existing infrastructure. And they came back and said, well, maybe.
Yeah.
And that's kind of where we led.
Maybe they could figure that out.
Yeah,
or
it's
it could
more
be done.
maybe that it could be done is
Okay.
how I mean, it was very high level how that conversation unfolded, but they said they were going to be here today and we were going to talk through some of those things. So
Yeah, the map that was sent around, I had a hard time believing that the scale was right on that map, that the figures they threw on there, that they fit.
meaning what they put on.
Yeah.
Yeah.
It just didn't look like they were the right size, but maybe they were.
And they were used. So I had what I sent them was the site plan from the 2008. So it was missing what was done in 2019, where they added the 3 drying beds on, kind of where the old dryer was and where the building is that keeps the solids. To the right of that, there was where they expect to put the 2 facilities. There's a drying beds there now. Now, could they expand off that drying bed, because that's some serious concrete through there. Because that you could probably build a tank off of what's already existing between the footers and the structure itself.
Well, I was surprised at the scale, it would fit.
Just the size,
And so on.
and then
What-
coarse asphalt, so the water.
What do we have to get
Separates the
accomplished
sides.
before they join us?
Just pretty much knowing what we want to ask them, but also, we have asked them for a preliminary design for an SBR system. And I don't know if they'll be bringing that with them, but they did caution us that that is not as friendly to salinity exceedances.
Versus their technology.
Yes, yeah. So that was interesting, but still, it would be nice to compare. The other thing, I wish Mark were here, because he kept talking about, if we use the existing site and we build new tanks, we can put some of the equipment up on top of those tanks that are like 20 some odd feet high. But I don't understand how that would work.
What kind of equipment was he saying to put up there?
I think he was thinking maybe either a building like the office building or controls, you know, a hut to house electric stuff. I don't know. He said they did it in Perryville, and I looked online and I didn't see that when I looked at the Perryville, Maryland plant. And then he said, oh, it was something about some screenings or something that they put on top. I don't know. It was an email exchange, but certainly, I guess one of the questions we'll have to look at as a team is, if we elevate buildings, elevate tanks, is that more cost effective than putting a berm around the whole site? You know, that's one question. There's a lot of other questions, of course.
I think it's more cost effective. I think a lot of the berm was to protect the drying beds,
Yeah,
and I don't really see any reason to protect the drying beds with your life.
no, and
No, because you won't pour if you know something's
Can't you
gonna
just
happen.
close them if there's a storm event coming?
It has on the front where the opening is, where they take the skid steer in. You can put basically boards to close it off. But again, if you're planning for it, I mean, you know, if you were to pour a week ahead of time and then a storm comes out of nowhere, that's one thing. But if you know something's gonna come down the pike, you're not gonna pour. So you wouldn't be utilizing the drying beds. I think at the end of the day, the biggest question you're gonna be faced with utilizing the existing site is gonna be access in the future.
right,
And that's where you have the ultimate discussion with DelDOT, because that's the only other player that's in the game as far as what happens on Savannah Road. Because you got to get to American Legion Road somehow.
right.
And I've always said the other option is you go across the bridge, Freeman Highway, and you drive the bike path
Mhm.
all the way around and come on the backside of American Legion Road.
Does that elevation work?
It's
Is-
higher.
Is the bike path wide enough to support that kind of traffic, that kind of?
If you want to get across there, you can get across there.
Oh, I understand that, but
Not to the
what-
degree of like, depending on what you're bringing in. Like you're not gonna be able to get fuel trucks down there.
Right.
You could probably get a 1/2 ton truck or a 3/4 ton truck, but
but it's sort of an interesting idea. I don't know the economics, but if you had to, you could conceivably
yeah.
elevate that piece of the trail, put a better bed in, and make that more suitable as a emergency access driveway that could support
Yeah.
tank trucks or whatever else needed to go in there.
And that comes down to a partnership between intergovernmental relationships.
And
which-
we are
Yeah.
champions at that, and regular practitioners.
Like your
Wow.
I like your attitude, but but in the next 40, 50 years,
Yeah.
That would do it. You could get in and out on an emergency basis and so on. But you'd still need American Legion Road for
Normal.
normal
No
stuff.
operations.
Yeah.
And if you got the sludge squeezer machine,
Belt filter press.
yeah, that's what I meant.
Yes,
Let's talk about that.
yes, I'd like to. And can we take Daphne off mute so she
I
can?
think she put herself on.
Oh,
mute.
she did?
Yeah.
Okay,
Okay.
okay.
Okay, belt press.
Yeah, why would we need drying beds if we had a decent belt filter press?
You
And let's start up, can I start,
Yes.
back it up a little bit farther? Do we have a belt press now that's not in operation?
there is no, it's a different, it's a centrifugal press. It's not the same and it's beyond repair.
I see.
Yeah. You
I
can,
mean, it's not cost effective to repair it?
it's scrap metal by now. The question is that, so Sussex County has a 53-foot trailer that they have that's mobile, that has a belt filter press.
Oh.
And we've used it from time to time,
Mhm.
but it's gold. I mean, when it comes in and you set it up, it's a seamless machine. It does the work of a drying bed. So you can do, I think it's between 2 and 3 drying beds a day. You can actually push through that. So a normal drying bed takes a week to 10 days. You can do about 2 to 3 drying beds a day with that machine.
And this
that's
is the 300 to 500K thing you were talking about?
And what was
That's
the
a mobile. I'm talking permanent. That was a mobile unit.
Yes.
and what was the capacity of the one at Berlin? Does anyone remember? I don't remember hearing capacity
absolutely.
measured there. Or
Yeah.
stated. Okay, go ahead. please.
Well, we've talked about it. So it's been in the
Because
budget.
isn't it, do I understand? I'm sorry to interrupt.
No,
you.
you're fine.
Do I understand correctly that the drawing, the quality of the sludge that's hauled out of here is of, I'll call it, well, I'll say poor quality in that it's not,
It's
is it-
too wet.
it's too wet,
Yeah.
right? And so would it be effective for us to make that a more efficient operation, part of the operation?
So the way that our
They're right here.
current contract, Sussex
Sorry.
County for solids handling,
Right,
we're essentially doing, instead of us sending our current flow to them, or our current solids to them, which is too wet, so they're putting it through their dryer anyway.
right.
For them, it's easier just to take our liquid and for them to dry it at their own dryer.
It just takes more trips to get all that
Correct.
there.
And it ends up working out, like from a monetary standpoint, it still is a good relationship. It's just a question of, if you wanted to still do solids handling, to me, it's, you just won't use the drying beds. You could use the belt filter press.
And is that a service that you're under contract with the county for, or is that just a handshake agreement?
No, it's an actual contract.
And is there a term on that contract?
I'd have to go back and see if there's a term on it, because it's us, Seaford. I think it's us, Seaford. Possibly Georgetown, and I don't know if Tidewater's in there as well.
And what is your annual cost for that?
Oh my gosh, I'd have to go back.
You know what it
It's
is?
not even in operation for a year yet. The agreement was signed almost 2 years before the facility was finished, because the facility's at Inland Bays. The drying facility.
So are there any limits? How far that could go to meet our needs?
Right,
How the county agreement that you're talking about? Is there some sort of cap down the line where, I mean, because from various things we've talked about, I had the distinct impression that the drying beds is probably the last thing we need to worry about.
Mhm.
We already have, you've said several times, we have this agreement. How far into the future could that meet our needs without us having to figure out some better way of handling solids?
I think I'm pretty confident the Sussex County would have to go out of business, or the permitting related to it would have to be reneged for some reason. And that would be through like DENREC. So I'm pretty confident that they wouldn't take that out of place.
or deny the service to us,
Correct.
correct?
Yeah.
Okay,
When
It's
they dry the solids, they take it to land application or
Yep.
to a landfill.
land application, I believe.
So if the land application were reduced in some way, then that might impact us.
Yeah.
right.
Or it would then just go to the landfill.
Yeah.
As the alternative.
And I think the way that it works at the end of the day is that's Sussex County's burden. You know, the handshake is they pick it up, and once they pick it up, it's
It's theirs.
yeah.
Yeah, Han
So-
said something about, we can see in the future with the PFAS regulations that
It's a
land application may cease.
yeah.
But, so let me make sure I understand this. If we had a belt filter press, would we still send the solids to the county for further drying?
No, you
No.
would send the solids to the county, and the county would handle
The disposal.
the disposal, whether it be land application or landfill.
Okay,
Do you want a belt press?
Do I want one? I think it makes sense if you have that, if that or if that facility stays there, I think it makes sense. Because at the end of the day, I mean, even if you think about it from the standpoint of just operationally, right? Everything's there, you're drying it and then you're shipping it off versus having a tanker come in, connect.
Yeah,
It's a
pick it up.
finished product.
But I think there's benefit in having it set up both ways, because if you get into a situation where
Redundancy.
you know, well, not only that, is that if you know a storm's coming, you can really draw down on the digester to give you freeboard within the tank. if you're hauling liquid, just like you would if you're
Ah.
ready for a storm on the EQ side, you can draw down to give yourself freeboard.
You're
For a
saying
higher-
for storage?
Yeah.
Yes, yeah.
I mean, you gotta,
Yeah.
when you looked at that, the report, GHD was sizing, I think it was like a 3.5 million gallon EQ tank.
Yes.
The new one?
Yeah. To
Yes,
put it in perspective, the one that's there now, I believe, is a 500,000 gallons.
Yeah.
I mean, it was,
So more than
the
6
tank
times the
was
size.
bigger than the building.
yes. It was,
Were they
horrific.
supersizing it to?
Well,
Or intentionally, was there a reason for that?
That was.
I mean, was there science behind that?
They wanted the ability to store for events that would come through, because that facility, even at where it's at today, there's the reason why Berlin was able to put their infrastructure in probably a lot lower cost is because we have the hurricane standard that we would have to build to.
Right.
And we've talked about trying to figure out even putting like a tonneau cover mechanism on top of drying beds to keep them out of the elements,
Right.
but it never ends up working out from a financial. I mean, you could buy a belt filter press for probably how much it would cost just to put.
Cover those.
To do the glass at
Right.
hurricane rating?
You probably buy 2 filter presses for that,
yes,
because the 3 drying beds was $900,000. To put it in perspective.
To do the glass?
No, the 3 additional drying beds that was put in 3 or 4 years ago was about, I think it was between 700 and 900,000.
The what?
Yeah.
Really?
Mhm.
I mean, that doesn't look like it's high engineering at all to me. I mean,
yeah.
What was so
I'm
expensive
astounded.
about
and
it?
you know how experienced I am.
So, well, I
Did they
mean,
need supports because of the soils there? Is that why?
I believe it had to do with soils, and then you also had.
They must be on pilings.
Yeah,
Wait a second.
Their hand raised.
Hey,
Yes.
Daphne.
You're muted.
Hey,
No, no.
I
Yeah.
just had a quick question. I didn't want to interrupt the discussion. I just wanted to make sure that I was understanding, how does the solids discussion relate? Is there a relationship between that and the Narita question? So is the, what do we still need to decide? What questions are open if we go down the Narita pathway with respect to solids, or is this a separate conversation?
I think it's a separate conversation, but ultimately the recommendation that we make to the board will have to talk about costs and what we think is the appropriate configuration. So it's not getting us ready for the call with the Aqua Narita people, but it's very relevant.
Joining.
It's
No, no,
also-
that's fine. I just wanted to
Yeah,
make sure I
agreed.
wasn't missing something important about the connection there. Thanks.
Well, just for my own sake, my sense is the greatest vulnerability from a elevation standpoint, sea level rise and so on, are the drying beds. That's the lowest elevation of all the operations.
5.5 to like 6.2.
Currently.
So,
Or you could buy yourself
so this-
years.
right, so all this solids processing stuff, if you figure out different ways of managing that, you
Yes,
take that greatest liability away, you buy yourself room.
and if you elevate a belt filter press, you buy yourself even more.
Even more room.
Mhm.
Yes,
I mean, after that, I mean, judging from the GHD analysis, that's really the weakest link. After that, what's the next
No.
thing to?
You'd be at your admin building, and then you'd go
Yeah.
to the first floor of the headworks, which some of that equipment has been elevated. So I think it's like a 9.5.
Will any of that be affected by the work that you all are going to be doing on the headworks soon?
So when we did the VFD project, we actually elevated them another foot and a half. The actual electronics on the first floor of the headworks building. So it's pretty much a line as you go through. Your benchmark's about 9.5 feet. Once you get to that, then you got a problem.
And how long ago was that project completed?
About a year and a half,
What's
Okay,
the
and
top of the wall for the occupation? division?
9.5.
That's 9.5.
Yeah.
And there's still some, there's some blowers and stuff in the digester building that's at ground. That airs and blower at ground level would be,
Yes, on the backside. So that's probably in between, because that's also a low point, because that has a basement too.
Yeah,
Yeah,
Which one is that?
that's the digester building.
Oh, yeah.
The original digester, then they built on the left-hand side, the thickener side, they built that as part of the 2008 project. But the digester building itself, when you go in there, it actually has a basement to where it has all the plumbing for the digester, the actual digester building itself. And then once you go into the back, you have the big Azern blowers, which are in the back of the building at ground level.
So those are vulnerable.
So,
Yeah.
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 And is there,
Can they
Not
be?
hard
can they be
move.
raised? I mean,
oh, absolutely.
Oh, yeah.
right,
The tanks are the
And-
big things that are hard to, just pick them up.
Yeah. Because that's in a building. The tank itself, you're basically, if you're talking about trying to harden that aspect, I mean, you got the tank and then the building is off to the right side of the tank. So when you walk into the building, you basically walk through the center of the building and the two blowers in the back.
The Headworks project,
Yeah.
if we knew that we were staying here and we were gonna harden, are there things we would do differently there that would save us in the future?
you mean the Headworks project
That's
Gonna-
approved.
that's
and
approved to
it's
be
gonna
done?
Start in the spring.
Good question,
Yeah.
So
good question.
short answer is no. Everything we're doing there is we're replacing the Pistagrit in kind, putting the new compactor in, rebuilding the 5 mil, rebuilding the 2 mil. We talked about a redundant compactor at the 2 mil screen, and we got confirmation that from a structural standpoint, you could easily add it into the second channel that runs parallel to the other channel.
Okay.
So we have that confirmed. It wasn't a part of the bid to add that in because it was like 700,000. But we know from a structural standpoint, it can be added in for redundancy on the 2 millimeter screen. All the HVAC's getting redone, all the electrical work is getting redone. So really, at the end of the day, the Headworks is almost brand new.
What's
Wow.
the lifetime expectancy of all that work once it's completed? How long would you expect it to be serviceable?
So let's put it in 2008 was when the bond was taken out to do a lot of the work. That's going to be serviced in 2027, fully done in 2027. So
Okay.
fully paid off in 2027. So I'm going to say with salt air environment, probably about 15 years. New technology comes out, I'm going to say 15 to 20 years.
Alright.
The EQ tank is going to be the next big discussion topic because the top of the EQ tank, which Barbara knows this, is that it's starting to become oxidized and really it's flaking away. The top flange, not
What
the
is the
tank
EQ
itself,
tank?
but the top. Yes, the EQ tank.
What is the EQ tank?
Equalization. So it's
Oh,
used
thank
as,
you.
yep. So that'd be the next, and we're talking about that because you're gonna get a resolution in December about supplemental funding of 350,000, and that's one of the things that we're talking about. A change order to that project.
And the reason that's coming to us in December, you said?
Yeah.
Is just for informational purposes?
No, supplemental funding,
Oh,
original
but
1.75.
supplemental funding you go to Congress for, we don't practice that here.
Welcome to the show.
Hey, did we learn in Berlin that when they did their upgrade, when they went from their original plant to their newer plant, didn't they tell us that they actually raised the height of some of those tanks? Did they made them, I'm gonna say taller? I don't, is that the right word?
They had one tank and they built
Oh,
on top of
on
it,
top.
around it,
Yeah.
and they used it for as part of the new process.
Right, but they, in a sense, they increased the volume of that tank by
Yeah.
doing that, right? Isn't that right?
Yeah, but that was a concrete tank, and I
One
think
of the
you're
sludge
talking
tanks.
about another.
No, it's a glass, ours is a glass tank.
Yeah.
It's actually a glass line tank for equalization. It's not concrete. The clarifier, the old clarifier in the center is concrete.
How
Do you know what
tall-
that, I'm sorry.
Sorry, how tall is it?
14 feet-ish.
Okay, so we don't
The
really have
glass
to
piece,
worry.
the steel
about-
tank
Yeah.
is 14 feet.
If it's repaired, we don't really have to worry about.
How old is that
what's
tank?
in there.
Oh, that was before 2008. I think it's probably 30 years old.
And what's the lifespan of something like that? Anyone know?
25.
This tank?
We had a study done in 2018, 2019 by MBA, and they said it had about 5 years is what they expected. But the biggest issue was the top flange. So that's what we've been keeping an eye on. So what we did is we had the subcontractor to the contractor that has the bid, M2, sent out Penn Jersey to look at the tank and see if they could put basically, instead of having to worry about the flange around the top, put an extra bracing just below that all the way around. The issue was that the bolt pattern is not the same the entire way around the tank. So you can't just take an off the shelf bracket and put it up there. So that's what we're going through.
You know,
So excuse me, but is the new tank gonna be glass fused to steel also?
That hasn't even been
Oh,
discussed.
I see, because if it were, then it's just a matter of replacing the panel, not all the base and et cetera.
Correct.
So it's not apples to apples, a replacement of that kind of tank as opposed to a brand new tank. Because all of the base of it is already there, all the structural support and everything for the base.
The issue with the GHD report is they wanted to go 5 times bigger.
yeah,
Yes.
but I mean, is that a case of being over-engineered for our? I mean,
I asked
what
at one of the
parameters
meetings,
were they given?
They went off of what the flow was gonna be. I mean, that's if they knew what the flow and the limits were gonna be related to the permit, that's what they were basing everything off of. So ultimate is 1.75 million gallons of flow.
Right.
From an engineering perspective, they used from a GHD perspective, what they have as their standard.
I
And
think
that's
it's
the
too
tank.
big. If I'm opinion.
That's
Right.
another engineer criticizing another engineer, so.
That's our favorite pastime.
You can criticize. And Daphne's on the phone, yeah. a lot.
Yeah, I thought that was crazy, but I'm not an engineer.
I mean,
But it sounds like
if you had a tank that big, it'd be wonderful.
Yeah, but it
You know,
sounds like,
no doubt. But is it?
Then why do you need it that way?
right, the German School of
Well,
Engineering.
wasn't that all about storage, having more room to store things in the event of problems with
Yeah, I
systems?
I don't know.
What could those possibly be though,
The
some,
reason you have that tank there is because you have membrane.
Ah.
That, you know,
but if you're
That's the reason
abandoning
To
membranes, why
hold
do you
up
do
the
that?
flow until you get the
so
membrane
that the
clear.
Because-
screens.
No, when GHD looked at option 1, they did not look at changing any of the process that existed. But when you went to option 2 and 3, they looked at completely
Right.
abandoning the
Right.
membranes.
No, I get it, okay.
And really abandoning the membranes is a good idea, I think. From a sustainability standpoint.
Okay, so my basic question is, I was telling Barbara. I mean, I think every time I've gotten up in front of the public meeting for the wastewater treatment facility, my question has been about quality.
Mhm.
Going back and looking at last month's Airmark report, going back and looking at the tables that are in GHD. The one thing that's clear is that this plant delivers some very clean water.
Yeah.
Mhm.
To the canal. Is that even achievable with this Aqua Narita approach?
And I think we asked that and they came back and said that they, if I can remember, because I had to step out, I thought they said that they could not get to the same quality utilizing only their technology.
Technology, but if you add the filter, then you could.
Their
Yeah.
filters or
Their-
our filters?
They're disc filters,
This
Yeah,
one.
so that is,
and I agree with that. If you had this filter system on your effluent rather than you would have sufficiently clean effluent. Absolutely.
and would it be as clean as what is currently?
I have a hard time saying that because membrane filters are
It's drinking.
make extremely clean water.
Right,
They use it on drinking water more than they use it on wastewater.
Yeah.
And that's what that membrane's used.
the
for.
membrane, right.
I designed a membrane
No, Howard
filter
County.
plant for Perryville, Maryland,
Yeah.
which we, for their water system. And the Susquehanna River water. is
Source water.
And so Perryville uses it. It's great for
And it's just
making
taking the
drinking water,
sediment
but
out
for
of the water.
wastewater, I don't
Yeah.
see it as a perfect mix. I think there's other sufficient capabilities from other types of filters.
Yeah.
So,
Would we need a second 2 mm screen for the headworks if we didn't have membrane?
I do not think so.
Well, and that's the reason that it was discussed is because if you were to ever have an issue, it's having it. So like the issue was, and then you come into the cost benefit analysis, is is it just gonna sit there? Or are you gonna run them simultaneously? Because to invest $500,000+ into having it there, what are you really gaining?
What you don't have are clarifiers.
Yep.
Because you have membrane filters, you don't have clarifiers.
Right.
So those tanks are not there. And
Right.
of course, if they're batch reactors or in the rated system, you don't have clarifiers either, because
Right.
they are the clarifier. But that, if you wanted to change to a disc filter at this plant, you'd have to build clarifiers
Oh,
prior to the filter.
I am reminded of something that, go ahead, I'm interrupting you.
if we did to the existing treatment train,
Yes,
yes, okay, but
Yes.
not with Aqua Narita.
that's correct.
Okay, sorry. Go ahead.
I'm reminded of what Billy Bob Boy said when we did Berlin tour. And didn't he? I don't say that in an ugly way.
Remember
But
his
I just
name.
don't remember his
Jamie.
name. He was
Jamie
good.
Lachin, yeah.
Jane,
Oh, that's his name. Okay, thank you. Nice guy, great personality.
But you're right.
Yeah. Didn't he talk about a particular technology that they have allows them to avoid the use of chemicals in their treatment processing and the advantage of that associated with the costs, the fact that they're not having to incur additional costs? You remember him talking about that?
I think he was probably alluding to phosphorus removal, which he probably didn't need to add additional chemical for phosphorus.
And what was
I
that
don't
chemical?
recall it exactly, but that'd be my suspicion.
Okay. Does that sound familiar to you all?
Yeah.
You remember?
I don't.
But he was saying he
remember. I thought-
only used
I was very,
2 gallons or something like that.
yeah,
he
and
did.
there was a great cost benefit
Yes.
towards the operation. And it was derived by the treatment that they were able to do, I
Yeah.
assume mechanically.
Yeah,
so-
the plant is made for the removal of phosphorus also, so that the discharge, you may recall from those batch reactors, goes into that small tank before it's fed in through the filter.
Okay,
And that tank had a mixer designed into it and a chemical feed, and mixing an iron or an aluminum sulfate into the water precipitates the phosphorus, any remaining phosphorus.
okay,
And thus that precipitate is then removed by the filter. So what he was saying is that he's getting good phosphorus removal in the SBRs prior to that tank, so he didn't need to add very much chemical to get the phosphorus out of the water.
And
So-
supposedly with the Aqua Narita process, we wouldn't need to add chemicals.
That's right, although you'd probably, at not a huge expense, you probably want to have the capacity to be able to add a chemical, have a mixer and, relatively small change compared to the overall cost of something, just to make sure that you're getting the phosphorus out of water before it goes into the canal.
Would that be in the, that fourth tank that they showed? That, post EQ tank?
That would be the place to put it.
That's
Yeah.
neutral limit. It's a neutral
So that gives you the ability to have a nice
So you
continuous feed into the filters,
have to have.
rather than the big splash coming from your decants that you're in the rated tanks.
The, I'm wondering if the talent we have is, with the talent we have assembled here, if we'll be able to figure out what an appropriate reuse of existing equipment would be if we recommend the Aqua Narita process and try and figure out how it best fits in at the existing site.
Mhm.
So things like what's the cost of, those new, Narada 1 and Narada 2 tanks.
I think you'd need your engineers to do it.
Yeah.
I think you would need your engineers to do it. I think it's more extensive than us.
Yeah,
I mean, I think we could give
But we
input, but
What about if it was a blank slate? Like a blank piece of land?
certainly
they
the
were-
input from Narada. You would start with, but then your head works, your sludge handling,
Cause they're only,
those facilities still need to be nailed down and. And you need your engineering firm to help with that, especially put prices on it. You got structural engineering, electrical engineering.
You're saying like a greenfield thing, like if we moved across Freeman Highway?
well, if you move across the canal.
On this side of the canal.
What's the name of the new development that's going in over there?
The plus
Level
of Shangri-La.
Yeah, let's condemn that land.
Yeah. Yeah,
That's a great idea.
yeah,
Like in the Kennedy property?
yeah. Yeah, that would affect the prices of the plots
Get a
very
lot of spray,
quickly.
get a lot of spray irrigation. on
Yeah,
it.
but it's buffered. See, the whole thing is it's buffered.
Yeah,
on
right.
all sides.
That's true. That's true.
It is.
I like that idea.
Yeah.
Yeah, welcome to Lewes. Take a deep breath.
Love it, you can look down. But it all comes down to sizing, because you'll run into an issue where how much is it gonna cost you to retrofit? Versus how much is it gonna cost you, because you already have a regional pump station on that side. That theoretically can go, if it had the correct pumps, and if the money was spent theoretically when they put the line in from Sussex County. You could have sent the flow back.
And we
towards Sussex
talked
County.
about that the other day,
Yep,
right?
but it's just Gills Neck Road, so
Right.
Earl will be fine with it.
Yeah. Do we have, speaking of that, that pipe and the valve and so forth, has there ever been a cost provided, estimated for making that a two-flow system,
Yeah, you have to dig up the road.
the whole road?
Yeah, so what they
So the
did,
pipe is in the road bed?
yeah, it's scrapped. So what they did was, when they came from Sussex County, the handshake point, they ended up utilizing an old 8-inch water line that they lined. So they did a CIP liner,
Mhm.
and then it dumps into a gravity right where Schley comes out. And then it gravities from there down to pump station 4. If it was force main all the way down, then it's a matter of the capacity of the force main and being able to reverse your pump.
Okay,
But that doesn't exist because you're dealing with gravity. So you would have to install force main to go the other way.
and would that force main only have to run from station 4 down to Schley, or all the way?
You,
the whole one?
you would run it to, if wherever you would site your new facility, if you cited it there.
Well, I don't want to take over this conversation, but it seems to me that if the BPW and the city is investing large amounts of money in the headworks,
Mhm.
that it makes sense that we're buying time there at that facility, and that means that we're going to be committed to using the headworks that are located there on that piece of land on American Legion Road for the next at least 20 years, 50 years, something like that. So I don't understand what we're talking about without also talking about this connectivity piece with the county and, making sure that redundancy, and I think of it as redundancy, maybe I'm not applying the right descriptive.
No, it's 70% of your flow.
Right, so shouldn't we make sure that is robust and really serving our future needs? If we are also now investing in the headworks, and which means that we are committed to keeping facilities on the bay side of the canal.
And I think that comes down to what the flavor of not only this committee, but the board, what they decide. Is that the correct location for it? The headworks, they had to put money in the headworks. There wasn't a piecemeal, there wasn't anything to get by. Your 2mm screen, your 5mm screen were basically, I use the word eaten up, and then the Lipactor was a technology that could not be replaced. You had to put a compactor.
I mean, given the
So,
reality of everything that's in that GHD report and all the conversations that have been happening since that thing came out. I see this Headworks project that you're referring to as simply buying the time until we get that next thing figured out. I mean, we need that just to stay operational.
yeah, but I think what I'm suggesting is that any future plans should be built upon the assumption that those headworks will be used for that future operation.
You said something about lifespan earlier. I asked you the
15,
question, and it
20
doesn't sound like it's gonna last that much longer.
You mean the headworks?
The brand new Headworks.
Yeah, 15, 20 years.
Okay,
And that's your lifespan.
that's not 50 years, that's 15 years.
Yeah,
But that's the lifespan for Headworks, no matter.
if you build a new one, I mean,
Yes.
it's
Right.
all about.
You just
Right.
gotta know you're gonna build
Right,
three of them.
and so, right,
Yeah.
and we're spending over $1 million if I add all this up, plus your supplemental that you're gonna be begging.
1.75 million and 350,000.
Plus another 350,
No.
no,
it's
total.
2.1 million.
The point is, you're gonna do it 2 more times in the next 50 years.
Yeah, right,
No
and you
matter
would have
where
to,
you are.
as Donna said,
Under
you'd have to
research.
do that anyway, regardless if you build another.
So where I think, at least
Some
my summary is. The lowest stuff is the drying beds.
Mhm.
You can solve that roughly for $500,000. Then you move up. And you're doing the headworks, and that's a step in the right direction. So you could stay here for 10, 15 years. Keep using the existing technology. But because you've identified Aqua Narita and other options, you could also migrate to that for some unknown number that's more than $3 million. And probably reduce your operating cost, and that's an option you could do here. And long-term, you could, but that's the option that should be measured against the county. And that's where I think you started this whole discussion, is that right?
Sort of, yes.
Yeah.
Yeah.
Rita or some similar thing. And that's $3.2 million minus some stuff that gets reused. Plus some other construction equipment. So call it 7, call it 8 versus the county.
Are there standard costs for concrete tanks that we can figure out?
Precast concrete tanks,
Well,
10
that's-
10 years ago, we used to say $1 a held gallon. I suspect it's probably $2 a held gallon now. And
What's
that
a
was
held
just,
Is that the word?
if you build 100,000 gallon tank,
Mhm.
it would cost $100,000. $1 per held gallon.
Held, I'm sorry, I think you were saying hell.
That's
I'm
what my
sorry.
clients would say when I said that number to them. They go, oh, hell.
Yeah, I apologize.
$3 now,
Yeah. Yeah,
And- you can get a number for that.
It's not any equipment in it or anything, that's just the
Right.
tank.
Because that's what we need if we go with this thing, because we don't have enough tankage on site.
The only thing is if somehow you could utilize the existing tanks, but
Right.
your flow process isn't gonna be the same.
That effluent tank, for instance, that they discharge into. There's a tank on site that you could use for that.
That's about 288,000 gallons they want for the post DQ tank.
So
There's
$1 million.
tankage on site that could be used for that. You raise the wall of the oxidation ditch just a foot.
We brought that up.
Oh, yeah,
Yeah, that's what we were mentioning when we were saying about utilizing
Yeah.
the EQ tanks and also the tanks where the membranes sit. Is
right,
that
Yes.
that's all,
That's usable tankage,
yeah.
valuable,
And that's already on site, is that
Correct.
Yes.
right?
constructed.
These guys are gonna be here in like 15 minutes.
Yes,
Are there other,
Does Daphne understand what's happening at 4 o'clock Were
But
you
know what?
online?
We should introduce ourselves to
Yeah.
Daphne. Shame on me.
Hi.
Hi, starting with Austin.
Yep, I'm Austin Cowan, general manager. We met at the tour.
Yep, I remember.
And we know each other, we're neighbors.
Hi, I'm Donna Colton.
Hi, Donna. I'm Daphne.
Hi, Daphne.
And I'm Barbara.
I'm Sumner Crosby. I think we met on the tour.
Yeah. Very nice to meet you again.
And Mark, we saw each other the other
Hi,
day.
Mark.
And I'm Bob.
Hi, Bob.
Hi.
And I'm Daphne. I live here part-time and I'm really interested in this project, and Barbara has been nice enough to let me participate to some extent with the discussions. So thanks for having me today.
She told us you were the most knowledgeable. So,
Oh yeah, yeah, absolutely. I have really appreciated the discussion. It sounds like what we're talking about is trying to get after what options we consider other than, for under 1 and 2, kind of setting the county option aside. What do we want to have as alternatives that we're going to be weighing against each other? And it sounds like from the discussion that one of the possible options is the minimum amount of work to of short-term investment to get to a minimum acceptable threshold of resilience from climate. And that, and to me, to my mind, that sounds like one of the things that we're talking about is, what do we need to do with the drying beds? What are our options there? What do we have to do with the EQ tanks? What do we have to, and that sounds really reasonable to me. And then the other option being a larger initial investment with potential longer term payoff of what are the other technologies we could pursue with even other potential locations for parts or all of the facilities. So that's what I took away from what we've discussed so far, and it makes a lot of sense to me as long as I'm getting it right.
I would say you are getting it
Very
much
good.
right.
And that's why I
you can
said,
write the minutes.
when you,
Either you or AI.
So one of the questions that I'm assuming may come up in a few minutes has to do with the salinity discussion.
Yes.
And I was curious, either from you or from Mark, what are the relevant, they were looking at chloride levels. I mean, what would we expect? How relevant was that analysis with the different chloride levels and the degradation of the process?
I found it pretty interesting, that paper that they provided us for. Barbara sent it to me. For 2 reasons. One, I see that, as expected, we'd see some detriment to the biology with saline water coming in at a certain level, and certainly the seawater reach that level. The other thing that hit me pretty hard was like the second to last paragraph in the summary is, if it would take approximately 17 days to get it back going again. And
Here's your EQ tech.
yeah,
Yeah, right.
so I mean, that, that and our other question about startup, how long does it take to create these granules? Well, now we have that question, and now we also have the question, how long does it take to get the granules working again if you have saltwater intrusion? So
Yeah.
Those 2 things are relatively large issues in my mind in terms of the flexibility of the treatment process. And maybe it's not a problem, but something need to be constructed to handle the issue. And whether that's making sure that saline water never reaches the treatment plant, which of course would be beneficial, or something is built to shunt the saline water into while it's there. Also, as was pointed out at the last meeting that we just discussed, was if we stop the saline water from coming in by turning all the pump stations off, you will have pipes that are full of saline water.
correct.
Right.
And that water has to be bled into a system very slowly. So at least a shunt tank of some sort, or handling that water, needs to be done so that you don't upset the biological process.
And that shunt tank is basically a holding tank, is that
Yes,
right?
it's something that you could bleed the water very slowly so that the salt levels are extremely low and the biology isn't impacted by it. Because once you get that biology hurting, you're gonna lose
You're
your
killing.
treatment.
Right.
And
This isn't just a problem for the Aqua Narita. This is gonna be a problem with that, because you've been talking about this from the very beginning.
Anything in Lewes.
Yeah,
Anything particularly coming from the other side of the canal or other low elevation areas, we're gonna have this problem.
right.
Right.
And there are some treatment systems that bounce back faster than others. You know, you can do things about with maybe less expense than another alternative. And, you know,
So is this more vulnerable rather than less vulnerable
Well,
to
that's-
those kinds of intrusions?
I do not know the answer to that. I don't, it's a question that I think.
Right.
um,
The way I read it,
aerobics of it.
the way I read it is that this is a lot less vulnerable than your traditional activated sludge process.
The only difference being that the activated sludge process can be regenerated by taking the solids out of your digester and pumping them in and just replacing the dead bugs with nice soil.
So not
But-
17 days.
But the other thing
Right.
was that they had this salinity, high salinity level for weeks at a time.
That's true. That's true.
And that makes a huge
I
difference.
think you're right.
Yeah.
I don't.
So
I-
if
I-
it's
been repeated
I don't know that
24 weeks.
I don't know that what I'm seeing there creates the problem that I worry about.
Yeah,
I think it might be able to be handled in a very simplistic way that I'm just not aware of. But
Well, that
it's just a scary,
That was kind of why I asked the question about, I mean, what are the, you know, they had a scale of different chloride levels where things, you know, went from okay to worse.
yeah.
And I'm just curious what the relevant numbers are in our system or what we might see under various scenarios that you've hinted at in the mitigation committee.
I meant to look up what salt, pure salt water is in terms of
3.5%.
3.5%. Thank you.
ocean
Wikipedia.
salinity average is around
It's legit.
And,
34
and
grams per liter.
what were the problematical levels that we saw in that paper?
6 and 20.
Okay, so
Here.
it's substantially less.
3.5% is the maximum for seawater. I work for the Navy, so for ocean water, so I'm not fairly, I'm familiar with that part of it. It's that's a very high salinity for ocean, but
Okay.
we could use it as a maximum.
And the other thing to think about is because we are here and we have, if we get a disaster, Hurricane Sandy 2, Hurricane Jonas, there's gonna be a lot of fresh water
Yes,
coming down, and we are gonna be washed out by the Delaware River.
which
Most of
is
which is
nowhere like 3.5% salinity. Yeah.
Right.
Yeah, so
Right.
that, I looked it up because that's gonna, at least in my computer model that I just did. That's gonna be kind of a max,
Yes,
okay?
yeah,
We're gonna,
It's
the
no
threat
more than-
to the system is gonna be somewhat less than that. That's what I'm
Yes.
trying.
and it won't be for 10 weeks at a time. You know,
Right.
So,
Right,
So Daphne, have you done any work down in the Norfolk area? Like because they're obviously sort of ahead of us with a lot of this sea level groundwater inundation, how much of a factor is the salinity there? Are we worrying about something we don't need to worry about, I guess is where I'm headed.
I don't know. I can reach out and ask some people that I work with about it, but that's not the kind of, I don't do the work with the infrastructure. I do operational stuff. So, but I have colleagues on the shore infrastructure side who I can ask, and I will.
Great.
that would be helpful. Yeah.
Thank you. I mean, maybe then we're worrying about something that's not really something we need to worry about.
I go back to a plant that I worked on for Harrisburg, Pennsylvania. And they had an input from a manufacturer, a dye manufacturer that was extremely saline. And I can remember going in and looking through the microscope and watching the bugs just die off. I can't tell you what that concentration was. It was a 25 million gallon per day plant, so the flow from one factory was extremely small, and I'm sure that the concentration was nowhere near what you see in the paper, and it still was killing off bugs. And so I've just always been paranoid about salt, and maybe overly so.
Well, one thing that bothered me was the increase in the nitrous oxide emissions. 'Cause we don't want to see that. People don't think of it very often, but that's a greenhouse gas.
Yeah,
So we want nitrogen or nitrogen dioxide emissions, not nitrous oxide. And to
I think the levels of nitrogen are such that it may be extremely minute
Yeah.
number.
okay.
Are there other issues that we need to clarify before the?
The next 3 minutes.
Yeah.
Yeah,
Don't get any pressure.
How long does it take to start it?
Right.
What we're gonna do, what we're gonna do with our sewage well, that we make granules. And ask them if they had any concerns about salt and what it would take to replenish the system. If they did have a concern.
And I think that's where, because I look at it as almost like a strategic planning objective, because to me, it comes down to, is that where the plant should be? You know, as you look and the data supports it, is that the location where the plant should be? And so when you talk about investing into this technology as an example, is that, okay, if you were to source another location to put it, and I'm using Robert Kennedy's piece as an example, you can build that on your schedule and as you want it. So you're still operating this system while building this system,
Mhm.
so that when the day and time comes, you can build, you can have your bugs and go with that. You can do like the project where you would have the interconnection with the county and talk about the reversible flow.
Right.
That plays into being able to tap right off of that line and send your flow up to a new location.
Right.
That's how my mind works.
Yeah.
what's
Yeah.
the
I appreciate that.
ratio from this side versus the other side? You know, like if you relocated to this side of the canal, does that solve problems other than elevation in terms of pump stations, flow, all that kind of stuff, or is it really kind of a
It
simple
solves
economic
a lot
problem?
of problems. You're higher, you're 100 years higher. Your collection system basically pumps from where it is now to Earl Webb stuff, so you just need to pump some back from here across the canal.
I mean, you could theoretically, if you played this out, and I'm not an engineer, but I've stayed at a Holiday Inn Express. You could utilize the existing force main that leaves pump station 4 that goes to the other side
Right.
for pump station 8 to go to 4. It's just, you would need to have a massive project at pump station 4 from a holding capacity.
Mhm.
And also from, you know, that's gonna be an aesthetically displeasuring area.
Yeah.
So
Looks like they're
it's
doing-
it's one of those big kind of discussion topics that if you were to do that, that is an absolutely massive project. But at the end of the day, you also have a force main that already exists, and that in itself is a huge project.
Right.
So then you're just, yeah, you know, it's kind of
Could
a,
be aesthetically not pleasing on at the corner,
Yeah. And
But
what
ultimately,
about
that's gonna
the
have to happen.
difference effect?
but once it's done, is it gonna be aesthetically not pleasing?
and that's what it comes down to.
Well, we've got the art project.
You can,
Right,
you can
right,
make
yeah, yeah.
it, you can make it as pleasing as you want it to be.
The mural will solve
I-
all the problems.
Yeah.
Yeah.
So.
Yeah.
I mean,
And some Febreze.
in
You know,
California, they've got oil derricks that are hidden. They look like apartment buildings and stuff.
But my sense is much of that plumbing is gonna have to happen under the 3A or whatever it is now scenario anyway.
If you look at the GHD study, and this is differences of opinions, because this is just this is Alston's hat, this is not the board's hat, is that they were eliminating the wastewater treatment plant from the floodplain, but putting the largest pump station in the entire collection system in the floodplain.
Right.
So that's, they were sourcing the location of pump station 8 to put and redo a pump station 8 that would take.
So they're gonna have to solve that problem anyway.
That doesn't make sense, does it?
Well, it has
It's
to
in the report.
happen. It has to happen. Right? If you're gonna send all the waste to some new treatment facility that's on this side, you gotta
Get
pump
it
all
back.
the waste from down on the other side.
Mhm.
And the
Okay,
other
so
thing is that
it
that
looks-
waste, that level of waste will
All right.
increase in the flood,
You're on.
I'm gonna start.
because
Okay.
people won't be able to.
It's definitely.
People are gonna start moving out of that area.
Yes.
Hi, everyone.
Hi.
Hi, Paul.
Hey,
How are you today?
good, how are you?
Pretty good. So I guess, yeah, I just jumped on here. What do you guys need from me today?
Ah, I think, we're a little bit disorganized.
If
But-
you need another minute, that's certainly
No, no,
fine.
no. No, I think we'll be disorganized all day and for the next 2 meetings. So, we were-
Barbara, can you hear me? Bill Laporte?
Yes,
Yep.
Bill, hi.
Okay, good. I don't see a microphone on my screen here, so I wanted to make sure I was hooked up.
Should we say anything?
Yes, well, yeah, because not all of us were at your meeting. I think.
Right, and Daphne too.
And yes, we have, one of our team members is also on Zoom, and that's Daphne. We've got Austin.
Hi there,
who's
very
in the
nice to meet you.
room. You've seen him before.
Mhm.
Tim Ritzer, you've seen before. Donna, you were not at the.
I was not.
No. Myself, Barbara. And we have Sumner. Mark, and Bob, yes. And it looks like from you, we have Bill Laporte and Paula.
Correct.
Yes, okay, that's great. We were discussing a little bit earlier, the paper that you sent us on the effects of high salinity and trying to grapple with it a little bit. I mean, it's a paper from 2013 and I don't know whether your Dublin plant was built before or after that, but it was for the most part very interesting, but non-conclusive.
I'm looking back here, we may not have sent this to you guys, and I think it would be a good step, given the concerns you have. We don't share it with just anyone. But it is detailed reviews of the first phase of operation at the Ringsend plant, and there is information, a good chunk of information on salinity in there. I don't recall the specifics, but we can certainly assemble that for you. It would be more accessible, and two, just I think more pertinent based on what you guys are looking at. Similar kind of location there. So I will look to see if I can dig that up and get the okay to send that along to you guys.
That would be very helpful, Paula, because, one of the things in this report is, yes, a high salinity level certainly compromises the system, but it continued at high salinity for a long period of time, for the entire experimental period.
Duration, yes.
Yeah, and if it's just a shocker and lasts maximum 1 week, do you have data on what impact that has on the biomass? And,
Yeah, and because in that case, the sludge doesn't condition to it over time. It is, like you just said, it is a shock to the system. And how does it handle that shock instead of just adapting eventually?
Yes, yeah. And
I'm sorry.
Is there an answer to that question?
Yeah, will the Rings End report give us an answer to that question?
Yes, it should give you some more detail on that. Yeah, I'll review it and I'll double check. And if it doesn't give you that, I will find something that hopefully can.
Okay. That would be good because that continues to be a concern. Also, on the salinity end of things and the impact on the granules. And please, team members, committee members, please ask your own questions. I don't pretend to have all the questions. I have a few, but the whole startup of the plant and the issue of running a plant while going through startup, either at the existing site or at a site nearby. You know, you gave us some information about weeks or months to grow the granules to where they're the right size to be a full aqua narita type process. But can you go over that again for us and let us know whether there are benefits to a new site or to adapting or running in parallel at an existing site?
Of course. So no difference in terms of it being a greenfield installation or an existing installation. In either case, we will need to seed the reactors with conventional activated sludge, preferably. And that can coming from if let's say it's a new plant and you're keeping this MBR running, you can grab it from those bioreactors. Alternatively, you can use return activated sludge, waste activated sludge, or even digester sludge, understanding that sort of the quality of the sludge degrades as you go down that list. And I speak on degradation in terms of relating to the biology. Obviously, ideally, you have your nitrifiers, your denitrifiers, and organisms to remove phosphorus. And that comes from a healthy sludge that performs that regularly. That being said, we've started up with a variety of sludges, and we just have to be cognizant of, let's say there's a greater propensity for scum or foam to develop when you seed with digester sludge because it's just a lower quality. That being said, all plants choose a different route and based on what the requirements are. So in terms of the initial biological needs, it is that seed sludge. So it doesn't matter to me if we're putting that seed into an existing tank or if it's into a new tank. So that being said, the amount of seed that we'll use is going to be dependent on the flow that we'll take on at startup and the carbon concentration coming in with it. So essentially the overall mass carbon load coming into the plant. I want to know that because I'm looking to maintain a nice food or carbon, that carbon is food to the system, to mass, and the mass is going to be the sludge ratio. It's just a good amount of food to bugs so they can have enough food to eat, but they're also not being overwhelmed. So it's a feast or a famine kind of a thing. So we're trying to find a nice middle ground there. So in terms of the amount of sludge, like I said, it's going to depend on the flows that we have at startup and the loads that come with them. So if you're at an existing plant, let's say it was a new tank and you kept that ditch running with the MBR, you could use less sludge at startup and gradually divert flow to that Narita system. Conversely, if you went to a new plant, you could put in more seed or either at the existing plant. It's really not a difference. It's just how much seed you would haul between the existing site where the seed sludge is and the new plant. The more seed you use, the higher flow you can start up with. The less seed you use, the lower flow you start up with. And then you just gradually increase this. Some plants, it sounds like you guys, you have your existing system, you can easily get seed sludge. For some plants, it could be a whole new plant, and the nearest plant to pull seed is a half hour away. So that could be more expensive. So you would ideally start up at a lower flow requiring less seed sludge. So that's kind of the seeding portion. I know that's kind of an initial portion here, but I just want to make sure we do understand that. Does that make sense so far?
What food to microorganism ratio do you usually look for?
Let me see. Oh, well, I can tell you what, I don't know what you guys' design is right off the top of my head. I will look it up though. Usually I am looking to be between, in the design, we're designing for about 0.02 to 0.2, and that's pounds of BOD per pounds of mixed liquor. Let me bring up your design really quick here, guys, to see what we targeted you at. But generally, when we start up a plant, we're going to target something a little bit over your design food to mass ratio, just so we can get requires a little bit less seed. And when you're running a plant, you don't need to be exactly at that. There's a range of operation, like I said, that 0.02 to 0.2. But let me bring up what you guys are exactly designed at.
Well, I have the report here. It's
0.056.
0.056 pounds. Yep. Mhm.
Yep. So I would probably go maybe up to 0.1 to seed it with. Maybe 150% is nice. I could go a little bit above that. So there is flexibility with that, and we discussed that during the startup period with the engineer, the contractor, and of course, the city, since you guys would, really be involved in that.
Thank you.
No problem. All right. So if we're good on the seed, is that okay? Ready to move on?
Question though, how long would we likely have to run the systems in parallel?
Well, that's kind of the option. We can completely avoid doing that if you guys want to. We could bring as much flow and just put more seed into the existing system. That's an option. And you just bring that other one down almost immediately, or within a couple of weeks, let's say. The other option is, we diverted Wolf Creek in Alabama. We diverted that in 6 weeks. I think we could have accelerated that one a bit more, but I think we started at a fairly low flow rate there relative to design. I would have to confirm that. So I would say optimistically, 4 weeks, and then maybe on the lower end, 8 weeks. But again, you can start it up right away at the full flow. So a lot of flexibility there.
Barbara, I think a good point to make here is regardless of whether you bring it online with all the flow or gradually ramp up from day one of startup, Aqua's setting the plan up so that you are meeting permit regardless.
Yeah, I guess that's the ultimate thing we're getting towards here, is that I just want to make sure we understand the seed sludge, so that even though we seed with conventional activated sludge, and like we learned how we granulate, and it does take a bit of time, you will still meet your effluent objectives that are necessary. That is something that we are weighing against the operation here. So if you guys do have a strict permit right at startup, usually you get a little bit of a leadway with the new system. Then we'll just have to make sure we're seeding with more sludge, or we are doing a flow diversion so that we don't overwhelm what we have in there. Now, keep in mind, you're not going to seed with 8,000 milligrams per liter of conventional activated sludge. 8,000 is our design mixed liquor. You'll have a very difficult time settling at 8,000 milligrams per liter. So there's a little bit of a limit there until we start getting that granulation going. And granulation, to be fully granulated, it takes approximately 3 months under standard primary influent or raw influent conditions. So that is no primary clarifiers. But like Bill said, we'll still, operate to meet permit during that time.
Okay, anyone have questions about that? It seems optimistic that you could meet your permit limits. Yeah, when you don't have the granulation yet.
So it's still conventional activated sludge. And this is, again, it's going to be dependent, and there's a little bit of an upper limit here. in terms of like your BOD and TSS removal, like solids removal will be pretty consistent. It's about having the appropriate biomass relative to the load coming in. And that's where I say there's a bit of an upper limit where you can only seed with so much conventional activated sludge. So at about maybe 5,000, maybe up to 6,000. At that point, you'd look at granulating a bit and then pushing that rest of the flow in. And that's if you guys are expecting to start up at the 2.1 MGD. I'm not sure. I don't think that's expected here. It's really only a concern when you're looking at full design conditions.
Let me ask a question about this because I'm having a hard time understanding. When the granulars are formed, you put the influent, you continue the influent into the reactor. The grains are settled and you push the effluent out the top. How does that work if there's no granules yet?
We still settle the sludge and we maintain a controlled feed rate so that we don't lift that sludge up and out through the effluent weirs.
I see. Okay.
So the process takes longer initially, I guess the
Yeah.
settling period is longer.
And I can't recall if I actually hit on startup while I was in that presentation. I'd have to look back at the PowerPoint. And so again, I do have that noted here. I have a little extra info, the visual, if that helps. Yeah, so when you seed with conventional activated sludge, we're going to start with, let's say, a 45 to 60-minute settle time. And as that granulation progresses, you start seeing that settle time come down. So that's what we're seeing at the plants we start up now. So what happens is we waste off the lighter flock layer, and that's going to start clearing up. Let's say we have a 10-minute waste period. That waste is going to come out full of solids when we first open, let's say, a sample port along that waste line. Let's say 5 minutes into that waste phase, we're going to open that port again and see what it looks like. Well, there's still going to be solids in there, but they won't be quite as thick. And then we're going to wait 5 more minutes and we're going to hit the end of that discharge phase. So let's say for this scenario, it's a 10 minutes. And at that point, the waste should be essentially clear. So that tells the operators that they can cut another minute or two off their settle time. And then that last little capture will be cloudy with solids again. And as we're granulating, that will clear up. They'll reduce the settle time another couple of minutes, so on and so forth. So it takes a couple of months to hit the nominal settle time of usually 15 to 20 minutes. But those first couple of weeks, you see very significant drop-offs. You may see a 5-minute decrease the first week or two, and then you start tapering off to maybe 3 minutes a week to 2 minutes a week, and then you kind of polish it up there at the end. It's it's pretty cool to see the numbers and the waste change through that first month or so.
Do you have to make the tank larger due to this startup situation?
No. No, the startup situation is you're usually not at your full design flow and loads. So if anything, you're running at a little bit longer cycle time, giving it even a little bit more treatment capacity. Yeah, there's definitely no oversizing for the startup conditions.
So that wouldn't be the case if you started at full flow rate. I mean, if you were designing a 2 MGD plant and all of a sudden you had 2 MGD to start with, this discussion would change.
That would definitely change. If that were the case, we would want to, in the Netherlands and Europe, those plants are all located. They're hours away from one another. That's just not the case in the United States yet. So to haul granular sludge from another plant could get expensive. But if we absolutely needed to, in the case where we are pretty much at those the full flow design flows and loads, and we have, let's say, some fairly strict nutrient targets, we could supplement with the AGS seed. So you would use a mixture of both so that you can get your mixed liquor concentration target. But essentially, when you're by getting that even just a small portion of AGS in there, you get over the initial hump of granulation. Granulation, it looks a little bit like a hockey stick. It starts off a bit slowly, and then you'll see it skyrocket. It's just as those granules start small, then they get a little bit bigger, and then they start really taking on that carbon. So that's kind of how you see that the granulation change relative to the flow there. But again, that's a pretty rare situation and maybe more likely for an industrial site, but it can certainly be accomplished.
I understand. Thank you.
Yep.
Donna, you had,
Well, I'm just, so I heard you say that you would meet your effluent permit requirements, even though your sludge is not gonna be fully ready to go and be the little granules for 3 months. Did I hear that correctly?
Yes. Now keep in mind, we're seeding with conventional activated sludge, which provides similar treatment. It's just you're not getting up to that full design flow and mixed liquor. So yes, you can still target your effluent objectives during startup as well. We may be a little less aggressive with the granulation rate. You may need a little more seed at startup. It's all something that is very project specific.
Now, this is an off the wall question, but
Mhm.
in most of the applications where you're utilizing this technology, do you see the municipality when you're dealing with a municipality, do you see them owning and operating, or do you see them owning and contracting?
It's a mixture. We really have no say in it at all. So I work with our plant in Kahului, the Kahului Airport in Maui. That one is a contracts firm. And remember, that's just a small scalping plant. They definitely don't keep that staffed all the time, or will not once we get the contractor off site. South Sioux City, Nebraska started up this summer, predominantly industrial installation. That is also a contracts firm. Everyone else is either a municipality or a utility.
And in those municipalities and utilities, do you see the majority of them contracting out the running of the plant, or do you see most of them doing it in-house, meaning
they're doing it in-house? And I should be clear that the two contracts firms, the one in Maui that is owned by the Kahului Airport, so the Hawaii DOT owns it and then hires a contracts firm. And then the same thing with the South Sioux plant that is owned by South Sioux City, Nebraska, but they've hired the contract firm.
and I think I remember you said that it only takes a couple of people to operate the plant.
Mm-hmm. Yes.
And it can be done remotely, like.
Yeah, in terms of monitoring and even controller or set point changes, that can be done remotely. Obviously, you should get a body on site, preferably if you have someone on site, they should be walking the plant every day for any system just to make sure, things look okay. And then really it's during startup, it's doing those, I've mentioned those waste checks as you reduce that settle time. You'll do that maybe twice per week per reactor at startup for the first few weeks. And then that becomes a once a week thing for the next month or two. And then long term, you can, alternate every other week. That's really the only on-site item in terms of the process control, other than the sampling and, lab tests. Everything else would be just standard, mechanical equipment, making sure you're keeping up with your, blower and pump maintenance.
Yeah. And how much of that extra labor that happens during startup is provided by Aqua Aerobic?
So we'll be there. We do not, the contractor typically, this is all going to be how, things are specified. The contractor will generally handle the cost of sourcing and hauling the seed sludge. They are also responsible for transferring it. This is not different than what Aqua does with any other technology. We go to site, we will supervise. Obviously we do the mechanical and electrical equipment checkout. Then we'll hand it over to a more process focused individual. And he will be handling kind of final checkout on the controller communications, and then he will supervise the seeding. During the seeding process, he will assist with assessing the seed sludge health and how it is behaving immediately after the seeding to get the operations dialed in for, the initial set points for that first week or two. That being said, we don't provide any additional support in terms of startup. That would be all on the team who's going to be running the plant long term. And again, that's really no different than any other system. We can, of course, provide additional time on site if you guys do request it or specify it.
I thought I read something about you provide training.
Oh, yes, process training is part of it. Yes. And they'll do mechanical and electrical training as well. That should be standard for any manufacturer. Yeah, sorry if I to gloss over that. No, that is just a standard part of the startup.
Hey, back on startup for a minute.
Mm-hmm.
So it would be logical for us if we were to start up at a low point in the season. So let's say it's February,
Mm-hmm.
and we have a tank or a series of tanks that's able to do 2 million gallons. Do we fill them up and wait for it to start to settle, or do we start running 600,000 gallons a day and cycle it every 10 minutes or so to get clean water off the top?
I guess I'm a little confused as to what the question is here.
My question is given that we would probably have a system that's 2 million gallons, and we really only
Yeah.
need 600,000 for
Mm-hmm.
the next 2 months.
Mm-hmm.
How would you vary the startup?
Oh, no, we'll just, so the startup, that actually would make the startup nice and easy. You wouldn't need a lot of sludge. We can start at a little bit longer cycle time, and you'll just run at a longer cycle time because you don't need to push as much water through the system. Yeah, that really, it's certainly not a negative difference for us at all. It really just would be less seed sludge is required.
So building on that question, I'm curious about the week to week, month to month fluctuation in the flows because of tourist changes and so on.
Well,
Are there any factors there that would confound?
as long
Just like this.
as long as you still have the county sending you flow, it won't fluctuate.
Okay.
But
The
when we
county's-
didn't,
If a county stops, then you'll fluctuate probably 45%. Yeah.
I'm
So
not
just-
concerned.
No, I was just gonna say you'll do between. I would say you average out about 850 to 950 in the summer, and that's including about 100,000 gallons from the county. In the winter, you'll probably do about 450 to 550, and that's taken, and then factoring in about 450,000 from the county on top of that number.
And that allows for the growth that's on the books right now.
Yeah.
So if the county doesn't send us anything anymore, does that create problems with maintaining the bug population? At low.
or spikes, because
Spikes, yeah,
Thanksgiving week flow is up,
right.
Right,
Mhm.
that's sort of where I was.
Christmas
going.
week,
That's-
Yeah,
flow
I
is up.
thought that was what you read.
January 1st, flow is down.
And so the other factor into this is that, and I know this is going way into the weeds, it's a totally really separate conversation, but under the current flow agreement with Sussex County, if we were to say we're gonna build 1.75 MGD, the county has the ability to come to us and say, I want you to build 2.75 MGD, and I will pay for the million more gallons, whatever that cost differential is. They have the ability to do it.
Personally.
Yeah.
If they want, like, if they theoretically want you to build a 3.5, then they have 50% of the cost. That's how the current arrangement is.
But we're not obligated to
No,
fill that. We
no.
could.
Yeah.
Okay.
I think to answer your question on the wide swings, Paula, isn't the Utah installation in a ski resort area?
Yeah, I was gonna chime in here, just because it could potentially be a concern here for you guys. Yes, multiple installations or current projects in very tourism driven areas. Um, even Wolf Creek, Alabama is, but I'd say the most the best example right now is in the Whitefish, Montana plant that's right outside of I should say that's the town or two west of Glacier National Park. And then it is the wastewater treatment plant for the Whitefish Mountain Ski Resort, or I should say that's where most people flock to. So beginning right after Christmas, I start seeing a significant flow increase by at least 25%. I'd have to double check that. Not only do we see the flow increase, I think this year I saw one of their influent carbon BOD samples was 3 times the design. And I was probably twice the design even for a good bit that month. They see another spurt, kind of around Labor Day. It dies down in August and then it shoots up on Labor Day as people kind of rush into the park for a last visit. So they're a pretty good example in terms of a lot of fluctuations. In terms of handling that, during the winter, we may run at, or excuse me, the fall and late summer, we may run at a shorter cycle time. I don't believe we've made any changes this year. And then we would run at, a little bit longer time during the lower flow and a shorter time during higher flow, so you can process a bit more water. We did not make any changes this year. The one thing that the operators had to pay a little more attention to in January was the wasting. Because the influent carbon coming in was 2 to 3 times design, it meant we were producing more sludge. So they just had to waste a little more aggressively that month. So it's stuff that usually that first year of operation, again, for any system, although you guys will have an idea of your history, you just kind of keep in mind what might be coming ahead in the season. And it's like for a plant that has a seasonal limits where they vary. For example, Wolcott ammonia, they target a very low ammonia in the summer. And then when they go to the fall, they change that set point in their controller to a bit higher target since they don't need to nitrify as far. So very flexible with that. And the plant that Bill mentioned is Purgatory, Colorado. That is currently in order for a small ski resort community, which will see almost no flow in the summer and very high flows in the winter.
We don't have that variable limit, seasonal limit thing. We abide by the same limits all year.
Yeah. Just an example, like where, in terms of a plant needing to be cognizant of what to look for throughout the year. Some plants may have, flow shifts, some have, target shifts. Just one thing to, as an operator, you should keep in mind.
So thinking about ski resorts, what impact does temperature have on the cycle of treatment?
Temperature, I'm not going to really change anything operationally. For any biological technology or conventional activated sludge or granular sludge, you generally hold on to a little bit more mixed liquor during the winter because that will provide you with a little bit more biology because during the colder weathers, your kinetics slow down. So that just means that the biochemical reactions are occurring a bit more slowly. With that being said, Aqua designs pretty conservatively, and we use your minimum wastewater temperature as our design condition.
Now, getting back to design, we received that overlay on the plot plan that shows a couple locations of those 4 tanks. Is that to scale?
That was scaled to the scale on the drawing, yes.
It was, okay. Okay. And whether or not we need all those 4 or whether we could reuse some of our existing tankage is something we still need to deal with as a committee. But what impact if we use, say, some existing tankage for the influent buffer or the post equalization tank, what impact does that have on the price of the equipment that Aqua Narita provides?
It really should not impact our scope at all. We're not providing the tankage, which would really, it sounds like that's what would be the difference here. Yeah, so no impact to our scope. That's going to be under the contractor there. Yeah, and in terms of retrofit potential, you guys have the design report. Each basin has the volume requirement. So obviously there's no consultant involved yet, but really we would ask you to definitely confirm the volumes that you have of existing structures. And if we think it works out with the volume and the hydraulic profile, if necessary, then we're all on board with you guys reusing what you can.
Yeah. Our problem is we've been given zero budget to
Unfortunately,
come up with a recommendation, and
unfortunately, I can't help with that part, guys.
yeah,
Yeah, I mean, I think I should double check my emails. I'm not the design engineer on this, so I can confirm with her. I don't know, or Bill, if we got any more detailed drawings than what you received that shows us, depths, elevations, dimensions, and all that good stuff.
Not
Hydraulic
of the
profile.
existing tanks, no.
Okay, that is something, I mean, we're more than happy to take a glance at that, you guys. Aqua's just obviously not going to take any response, cannot take the responsibility for, the plant design, it's, overall plant design.
Austin's not listening to this. Could you repeat that, Paula?
We can
Basically what she's saying is, yeah, and Mark, you may want to weigh in on that. The infrastructure there is existing and all the piping in place and whatnot, and the scope of whatnot. Yeah, you would need a consultant to get involved to fine tune what tanks can be reused and how that would be piped and whatnot.
I agree.
Yeah, the structural health is one thing, but yeah, if it's not within our reactors, Aqua as the manufacturer is, we certainly get involved. It's not to say we don't, but we don't do the design of that. We work very closely with the consultant engineer though, when we do get to that point. So I don't want to act like it's not something we care about. It most certainly is. It's just not something that falls under the manufacturer's scope.
I can answer it.
Yeah.
It
Well, it sounded like Paula said she could kind of look if she had more information about our depths and
well,
things like that.
what would happen is
Yeah.
your consultant
Yeah,
would receive their information on how big the tanks need to be, what kind of electricity is required to operate their system. And he would, in concert with them, work out tank configurations, sizes, depths, etc.
Perfect.
We would also look at your existing tankage and say, well, here's a tank that instead of tearing it out, let's reuse it for this process. And they would go to Aquarobics, is that a viable alternative? And they would say yay or nay to that. Such as an influent storage tank or your outlet tank. Can you use existing tankage for that? They would just go back and forth and making sure sizes meet Aqua's needs. But they're not going to say, well, the walls are only 12 inches thick, they need to be 16 inches thick. They're not going to do that type of thing.
okay,
You see what I mean?
yeah, okay.
Yeah, that's perfect. I do have this, Barbara, in that design report you have, it does detail the equipment we cover and the installation services, but he described it perfectly. Our design and even our cost is only for the Aqua Narita system and the ancillary basins that we work with or that are detailed in that. But the engineer is the one who will put together the overall cost estimates for the installation, the construction, et cetera, et cetera.
Well, on the Whitefish plant, was that a retrofit or was that a brand new facility?
That was completely greenfield installation. They do have existing lagoons. Idaho Springs, Colorado is a retrofit of 2 SBR reactors. And again, I can't remember if I hit on that as an example during my time with you guys, but I can shoot you some detail on that if you're interested in the retrofit approach.
The only reason I asked is because as I was sitting here, I was going through because the city of Whitefish has everything from their bid. So they have their site plan, they have
Mhm.
bid documents. So to put it in perspective, Aqua's technology and equipment that was used was 2.37 million. The total cost of the project was 20.2 million. For just to put
Yeah.
it in perspective. And
Now
then-
that is a new screening, grit removal, that, or maybe, no, not new headworks. Trying to think downstream work. I mean, it was more than just our stuff, obviously, but yeah, that was a completely new site, new lab. It's nice, but we're just a piece of the pie.
Uh-huh. One thing we noticed when we were at the Berlin plant and saw your disc filters out there,
Mhm.
flies.
Oh, filter flies. Those are a byproduct of wastewater treatment. They
You know
can't.
you got clean water if you've got filter flies.
No, no, it's we have them in even in our research center in Aqua. Wolcott, Kansas gets them. It's just something as it gets warmer out. It's not like that water is drinkable. Please don't drink any tertiary water, guys, even if it looks clean. So no, that is not uncommon by any means. There are a couple of quick fix chemicals you can throw at it that kills off the larvae. But it is just, unfortunately, it's a byproduct of that tertiary treatment in wastewater. I forget the name of that little quick fix, but I can shoot that over with a little bit of info because they are very unpleasant.
Yes.
Is it a Sakota?
I'm not sure.
Sakota fly?
Yeah, the
Just
quick fix would be-
midge flies.
Midge, okay.
Midge flies.
True. Yeah. Now, tell us
And
about,
oh, sorry, go ahead, Barbara.
no, if you could get us that information, that would be helpful. Tell
Yeah.
us About, I know we asked for a design report on an SBR system from Aqua. Are there reasons things we should consider about in choosing one over the other?
Sure. Yeah, I know I asked your design engineer today. They're still working on that design for you. I mean, the SBR is going to be a bigger footprint and more energy intensive long term. Equipment wise, and this is going to be something with you guys not having a consultant on board yet, you're only going to be seeing the equipment cost and the energy cost. The Narita equipment will be more than the SBR equipment potentially by a bit. But the O&M comes out, or excuse me, the life cycle cost for the Narita comes out lower due to reduced chemical use and the energy use. I haven't looked at this design yet, so I can't be specific here. Let's see. So that's really, the design part is essentially usually the big stuff is your footprint and your costs. Obviously, those are a couple of the big drivers. Operations wise, you're going to certainly have more operators with experience with an SBR. However, the Narita system is still the process knowledge or experience that comes with running an SBR any activated sludge plant is transferable to the Narita system. I know everyone looks at the granules and they are very impressive, and I still am amazed by them whenever I pull a sludge sample out of a reactor, but it is still the same biology. So when you have an issue with foam, or if you have an issue with scum, we're still looking at a lot of the same root causes. So the operationals knowledge is similar. I just think the SBR is probably quicker for someone to jump on since they are much likely to have run one. Yeah, I would say that's really it for me. The guys out in Idaho Springs, Ed, that retrofit, he ran an SBR previously and he jumped over to it, completely seamlessly. He was definitely the most prepared. I know you guys have an NBR right now, which is an advanced treatment technology, so they should have no issue running a granular sludge plant. And it's certainly comparable. I would say less and time intensive without those membranes.
I would hope so.
I think I told you guys they remind me of bamboos picking fleas off one another when I saw them cleaning them. So We'll definitely try to avoid that.
Yes.
Okay, anyone else have questions?
Salinity?
I brought it up with the gang here a little while ago, reading your, the paper that you supplied and discussion of, what salinity does to the, activated sludge.
Mhm.
And, the one comment was that, at towards, paragraph towards the end said that, high salinity causes these certain problems. And at one point, the granulars are affected, and it took 17 days to bring them back.
Mhm.
I believe it was a relatively high concentration of salt that created this situation. But I'm worried about what happens if there is, whether it's salt certainly would be a problem here, especially if there's flooding. But of any, an upset and bringing the granulars back and the loss of treatment, I'm just wondering what kind of history you may have of those types of things happening, how rapidly they can be brought back into compliance.
So, to be clear, you don't actually lose the granular structure, you kill off the biology. And that would be, again, similar for any activated sludge process. If you get something that is, hydrophobic or toxic, it is going to kill the biology. The Nerita process with that granular sludge is no different. However, it is more robust and resilient than you would see with conventional sludge, and it proves faster recovery. And this is because it's a denser biology. You see similar benefits from a fixed film process that uses an external carrier, like, the plastic pinwheels, the IFAS systems. With Nerita, that structure, that carrier is a biopolymer though. So in order to destroy that biopolymer, it would take a combination of a pH of 10 or 11 and a temperature of 70 degrees Celsius to actually disintegrate it and eliminate it. You're just going to lose the biology during a shock. And you have more resiliency with the Nerita system because these granules, they aren't completely solid. There's nooks and crannies that allows the water and the substrate, that food, that carbon, it allows it to penetrate into portions of that granule, and then it facilitates the growth of sort of backup biological populations. I know I showed a slide of this in my presentation of a fluorescent analysis that showed the little populations of nitrifiers even within the granule. So when you do have a toxic upset, it could certainly kill off the biology on the outer edge of those granules that are in more immediate contact with the influent, but you'll see a more rapid recovery because you have this sort of backup biology in the interior of the granule that didn't get impacted, and it's ready to start replicating right away. You compare that to a conventional activated sludge system that does not have that. It is just a mixed microbial community with no type of layering of their biological populations. And you're at risk of losing a significant larger portion of your biology. Therefore, you're extending your treatment time. I do have a couple of examples if you guys want to hear them.
Yes.
Okay. So I would say a good one, and this goes back a number of years, and it actually got Aqua kind of on board. One of the many things Aqua vetted before we agreed to license this over in the US and Canada, because we take on all the risk and do all the work ourselves. It was very important that, we could, we were, going to be representing something good. The APA plant in the Netherlands was started up in 2011. It takes on a very significant portion of its load is from a slaughterhouse, and I believe it's rendering, so can be pretty nasty stuff a lot of the time. They had a pH, they piloted there, so they had a pH spike to their existing conventional activated sludge process, and I do not recall if it was an oxidation ditch or a carousel, but just typical activated sludge. And it also obviously hit the pilot, and both of them had their nitrification knocked out. However, it took the conventional plant there a couple of months to recover, whereas the Narita saw some nitrification resume in a couple of cycles, and then by the end of the week, it was hitting their full nitrification target again. So that was obviously really good to hear, especially for a pilot system. And I am making a note here to follow up with a couple of examples with slides. Another one, and this was more recent, and it happened in the United States. We've been at plants running for a while now, and as you know, as great as they do, you are going to get a call one day where things are not going well and something's happened. And that happened earlier this year. It was, I think I remember the day, I think it was like Monday, March 5th or 6th. I got a phone call from Ed out at Idaho Springs in Colorado, that SBR retrofit, you know, probably just one of my best operators and knows his system inside and out. Calling me on a Monday night about 6:30, you know, dinner time out in, you know, Chicago area. So I knew something was up if he was reaching out to me, and it wasn't an emergency because it wasn't the customer service number. And he sent, well, I have pink effluent and red sludge. I went, oh my gosh. Well, it's nothing really on a biological side there that would suddenly cause this color to occur. And he knows that, but he wanted to let me know. And he said, I'm tracking down all the industries in the town here just to get and it's a very small community, just to get an idea of what could be coming in. And sure enough, he traced it down the next day. It was coming from a car wash that had been leaking, had repairs done the previous week, and had been leaking dye into the system all weekend. So it was only 20 gallons of dye, but that's, you know, enough for a small little plant to color it. So car wash dye is certainly toxic. It's non-biodegradable. It's not beneficial for treatment. And so we did see a degradation in our effluent quality for that day. And obviously there was a limit to what he could test, but he ran ammonia and COD tests. And then we also had our ammonia analyzer to check the trends. And the effluent concentrations were double what we usually achieve there. But they found their issue there and they immediately corrected it at the car wash. And we saw the effluent quality hit their normal standards about 1 to 2 days after that. So I do have the ammonia trends to track that to show you guys.
Okay, thank you, Paul.
Yeah, you're welcome. Sorry, a lot there, but they're kind of interesting to see happen. It's always good when they resolve successfully.
Yeah, it's that amount of time it takes to come back is what I'm.
Yep. And again, it's, you know, it can be a little bit different here and there, but we've done bench scale testing with pH spikes. And then actually when we seeded our reactor in Rockford, the demonstration reactor, I think we shipped 3 totes of granular sludge over from the Netherlands, and they were held up in customs on their way to the US. They saw seed sludge on it. So it went through.
What's in there?
What is that? It went through, I never traveled to Canada with my little.
Oh God, it got the Department of Agriculture
Manuals?
involved because
Yes.
it said seed sludge on it, and
Yeah. So yeah. So it actually took us getting, I think, a state senator or representative involved. And I think the sludge finally got to Rockford 2 to 3 months late, just in time to seed during the dead of winter in January of 2018. And we obviously, at that point, your biology is dead. It has gotten no food, no air for months on end. I mean, I get elevation sickness from flying. I can only imagine these bugs here. So we didn't know what to expect. We had no idea. And we dumped it in there, and the biology is still there, or excuse me, the backbone is still there. And as soon as we start feeding it with the wastewater, we start getting more bugs in there. And it would be like starting up a plant from scratch. Even an SBR, a conventional system with no seed, it'd be like just starting to fill a tank with an empty tank with wastewater over time. But we had this, again, like if this were an IFAS system, it would be like a plastic carrier. These granules are already in there, and you just need to give it a little bit of time to get some fresh bugs and some food and some carbon in there. And we started to see nitrification in a couple of weeks, and then we were hitting our TN and TP limits in about a month or so. So from pretty much scratch to nothing, it was really impressive there. So that's probably the best example and the most extreme one I can think of, but not very representative of day-to-day plant operation.
wondered about how you got the stuff over from the Netherlands. Yeah.
So
So I-
if I can just
Mhm.
summarize what I think I just heard, I'm the least qualified of everybody in the room. I don't have an engineering background. But it seems to me, given the physical structure of the granular design, it provides a greater opportunity for resiliency, a greater recovery rate
Correct,
than conventional systems.
correct.
The biology is basically the same. You've just created a different medium for that biology to flourish.
Essentially, that is the best way to phrase it. It is organized differently. The big standout is being that we're not adding any chemical or any external carrier to facilitate that morphology. It's just through how we operate the system. We waste out lighter flocculent material, and we have a nice strong anaerobic feed phase that facilitates strong phosphorus removal. And a byproduct of that is this biopolymer that comes out of it. And then that wasting just gets rid of the non-desirable sludge in the system.
Thank you.
It's deceptively simple when you see it kind of laid out.
Daphne, did you have any questions you wanted to ask? You take yourself up.
No, but thank you. I've been enjoying the discussion.
Oh, great.
Okay. Anyone else with questions at this point?
No, I'm good.
Okay. Well, thank you. This has been a helpful session. Yes.
Thank you very
Well,
much.
I enjoyed
you.
discussing with you guys again, and I will get Bill these handful of items that we discussed here. And of course, if I missed anything, feel free to follow up with him. And I know we're working on that SBR design as well, so you guys can start kind of weighing your options.
All right. Thank you
Thank you.
again. And
Thank
I'm
you,
sure
guys.
we'll be pestering you some more.
This is
Not
we'll
a
see you
problem,
later.
Barbara.
All right.
It's refreshing to see a municipality take,
Yes.
be this involved. It's,
Mm-hmm.
you're doing a great service.
Well, thank you. All right. Appreciate
Thank
it.
you, guys.
Thank you very much.
Bye.
Thank you.
Thank you.
Thank you.
So,
Well, it's certainly not the right venue to have asked them, but you have to wonder why other municipalities or developments or towns have not gone with their technology.
That was exactly the
You know,
question.
and I mean, if they've been in business, they have a plant and from 2011, why are they not winning bids? What is the factor? Is it cost? Is it the unproven technology?
Fear of the unknown, yeah.
fear of the
This is exactly the question
I
that
think
was
the
on the
answer
tip of
is-
my tongue.
Well, but
Press
it can't,
and
in this
wait.
venue, it's
Yeah,
not a
yeah.
good way to, it's not a good time to ask it.
Yeah.
No,
But how
Bob, I
do you
think you're
get to
right.
that? How do you ask that question? of
Once
right
they
person?
have a preliminary design. Then I mean, I've had people ask me that,
Mhm,
why are you losing bids on, with your team?
mhm.
That's a hard question to answer.
Yeah, well, I mean, just so I sent around the whitefish information because you can literally, it has the exact, like the plans, the concept drawings. It has the entire bid package. It shows the bid comparisons between the two people that awarded. The engineered estimate on that project was $16 million. The low bid was 20 million. The next highest bid was like 21.7. But what I was showing Tim was that it's interesting, and I don't know if this plays a factor, is that it seems like from a municipality standpoint, there's a lot more coordination because now you're going and like they awarded the technology bid in 2018 and then went and designed based off what they're buying from Aqua Narita. So then they had their engineers build based off of what Aqua Narita's technology is versus if you just do a standard SBR with a clarifier, you're not really buying into the technology because it's just a known process.
Right.
Order
It's
it
the
online.
same old stuff, right?
And does anyone have, is there an environmental concern with the polymer?
Well, that was gonna be the other question. She mentioned wasting a number of different times, and I don't know what that really means, but to me, that's the thing that I kind of want to know more
Yeah, I
about.
mean, is it a plastic space? I mean, what is it?
Yeah.
I mean, granted, they have faster batch reacting and everything else with their technology, but are we just adding to environmental issues, making this a polymer base?
Can Daphne, can you answer that question at all? No.
No.
I mean, polymers are not some of them are plastics, but some of them are not plastics. Some
right.
of them, so we don't know just from the term.
No.
Okay, I was thinking of that. Oh,
Yeah, I didn't think it was plastics.
Would a company reveal like their, I don't even know what you would call it, their award rate? Like how many projects did they seek versus how many did they not? Because it seems like it's not really a competitive nature. Like they're selling a technology that's completely different than what others are using.
Right,
So people are coming to them instead of necessarily,
you're not comparing apples and apples.
yeah.
You're comparing an apple with an avocado.
Well, and you have to buy into the whole program to go that way.
Yeah.
I mean, it's encouraging to hear that the guy in Idaho Springs trained with a conventional system was able to jump in and get up to speed quickly.
That could be the guy.
That could be the guy. And of course, I was looking at you the whole time. I mean, we have enough problems trying to find people to run this
That's why I
plant.
asked the question.
Yes.
Yeah. That's not gonna be, doesn't sound like it's gonna be as much of a problem.
Well, that comes down to a board decision on whether or not, if you own the plant, are you operating the plant or are you contract operating?
Right. That's a board decision.
That is,
Just
that's a true deep dive discussion that needs to happen.
Do we know
similarly.
what bids they've lost?
That's exactly where I was coming
Okay.
from. Because I didn't know if they're, I don't know how they structure it, because in my mind, like when you looked at the whitefish, they went to Aqua Narita and said, this is what we want. So they awarded that in 2018, and then they designed their entire bid based off utilizing that technology. So
There was no competition.
well, and
Well,
that's where it's a
They
little bit different.
pre-selected.
Yeah, that you pre-selected the tech. It would be like
The
us saying,
technology, yeah.
yeah, we
Yeah.
want to do MBR and we're going to use Suez or
Right,
Zweed, and then we would say build a plant to utilize that.
right.
So I don't.
So
I don't know
they've done
how
their
much they're-
research ahead of time.
Well, I
Yeah.
don't think Paula is of a mindset to tell you the answer.
Well, at some point, once they have a preliminary design and they present that, that's the appropriate time to ask it. And you can ask, how many bids at this level, how many bids have you prepared in the past 5 years, and how many projects have you been awarded?
Is there, for the folks in the room that have more experience in this area, is there anything that they said that raises alarms, that raises red flags in terms of the way the operation runs, when the challenges happen? You know, I heard a lot of good stuff, but I
Well,
heard
they didn't
stale.
tell you any of their bad tales.
Right.
They're not gonna do that.
But
you know.
given the way I mean, where are the vulnerabilities, I guess? Yeah.
Well, for us, that decision of are you owning and operating or are you contract operating? Because if it's a new technology, 9 chances out of 10 from a contract operating standpoint, you're not going to find somebody that has experience in
We've
it.
got the same
So
problem we have
you're
now.
teaching. You're going to teach somebody. So
Right.
it's either you teach
You're
your own
investing.
employees or you're
Yeah.
paying somebody else to learn the technology.
Yeah.
That to me is probably one of the most, I don't want to use the word concerning, but the piece that,
Challenge.
yeah, it is. It's a challenge. It's not to say it can't be overcome, but it's also if you run into an issue, what does that support system look like? And
Right.
they hit on it, right? You make a phone call, you have a 24/7 line, but it's not when you're hiring somebody, even if you have them on staff, they have to learn the system. And there's that learning curve of learning, what theirs
Right,
is
and you need
versus.
that person, and you need a backup, and you need, every time somebody changes jobs, you need another backup.
Exactly. You have to create a baseball team that you're almost a football team where you have second string, third string, fourth string.
But the thing that's appealing to me is the resilience factor, the rate at which the system seems to recover. At least from the perturbations that were described here. Maybe they're not representative at all relatable to what we might experience.
I think that's encouraging. I think also it's a plant that, you know, you could build here or there and it'd last 50 years. And it's gonna get hit by 2 hurricanes. And be out of business for a couple of days somewhere along the line. But, you know, it's a reasonable option. That probably doesn't cost as much as option 1 was described. It's a revision of option 1 that fits that seems to do pretty well.
Well, one of the scary parts of option 1 was that big tank.
Yes,
And
Right.
if I understand the course level analysis here, given the footprint advantages of this technology, maybe we don't need that massive tank.
I think they still said that it would be best to have it though. For some reason, I can't remember.
PhD or these guys
These guys,
these
to
guys,
have that 3 million gallon tank.
not 3 million.
No.
No.
Eight
That,
tanks.
that's,
the 480,000 gallon, which is
Yeah.
about what we already have.
yeah, they would utilize it.
Yes,
Okay, so we don't have to build that big scary tank that's
Right.
gonna turn a lot of people off.
Yeah,
right,
I think option 1 was twisted to prove a point.
yes.
Will to keep us from pursuing.
Option 1.
Right.
Um. And. You know, it's,
Well, it ultimately comes, I mean, having had conversations with a lot of people. Ultimately, the appetite for option 1 comes down to using the existing site and all the challenges that come from American Legion Road, hardening the site or building up the equipment, you know, high enough that it can deal with the flooding, or moving to another site like maybe Kennedy or some other thing as yet unknown. I mean, those are real choices we'd have to figure out, but you know, and no, as far as I know, maybe Austin is, but nobody else at this table is privy to all the dialogue that's been going on with the county
No.
over the last several months about, you know, how we could work together on an option 3, whatever it is. So,
Yeah, 3C now, I guess.
I mean, do you know Hans well enough or Austin, can we get a read on where the county is?
so they're doing their option 3C analysis, which is,
that's an ocean outfall, a new
Yes.
ocean outfall,
yeah,
right?
yeah. That is supposed to be done within probably the end of the year, I would think. So you're talking Christmas time. And then that's going to be fleshed out where everybody,
That's like a GHD level analysis, like what we've seen
PhD
so
did the
far.
report.
So I think you were on the call via Zoom, Bill Ullman. When we were talking with him about wetland stuff, he said, you know, back when Rehoboth was trying to find an outfall location, that spot on Deauville Beach was the best spot. He wasn't under the impression that there were other suitable spots along the coast. And I don't know how real that statement is,
Yeah,
but to
right.
me, he left me with the impression at least that it might not be so easy to find another site to put another diffuser set up.
What they did was they utilized a lot of what they already had, minus borings, from the Rehoboth Beach outfall to model this
The
scenario.
The new GHD one.
Because GHD did the design for Rehoboth Beach.
Okay,
So
so maybe they know just how much opportunity there is out there in nearby environments. Okay.
yeah,
Last time I talked to Hans, he said they hadn't been given permission yet to do the borings.
Yeah, they haven't,
They haven't.
not from the state.
So, I mean, a lot of
Is there
this-
any applicability of Aqua Nerita to the county site?
That's what Earl would like to see, if Earl were sitting here
Well, he's.
you need to use this technology at Wolf Neck.
at Wolf Neck. To
And what's-
lower the operating costs.
Right, I didn't get the impression that.
That might be a
that
good
Hans is
idea, but Hans.
necessarily-
is
No,
not
Hans is
Hans
not.
Hans is not
taking that
enthusiastic about that.
Who did you say, did you say Earl? Who?
Yeah.
Earl,
Web.
right, I just wanna make
Just
sure.
from a, I'm assuming it's just from an economic, just a
Yes.
lower
Operation.
operation.
Earl is always concerned about operating costs.
Yeah.
mean,
I
And
stand
I think
corrected.
that.
They did put out to bid the technologies.
Ah,
They did. Whitefish has the entire
Wow.
like background. They had 6 different technology bidders.
oh, this is great.
Yeah, and it has all the bid information.
He has sent that to
Aquanaerobics,
us as email.
Yeah, aqua aerobics, and then you go down through. And said they had 6 total. 3 of them were not comparable. One was a sanitary system. It was a low bid, but they had several potential adders that would have taken it above and beyond.
What is sanitary? Is that one of those biofilm things?
It's a different company.
The same,
As, yeah,
different concept or same concept or?
it's
Yeah, I think it's-
described as a process.
Yeah.
there.
Like its own separate, not like separate from aqua aerobic, like totally separate. Pretty interesting. But so, and now theirs was 10 years, so they were issued an administrative order of consent from Montana Department of Environmental Quality in 2012, and it took them 10 years to build the plant to meet that order. Which is similar to what happened with the board, because the board was issued an order. Gary Stabley knows this. 2001 or 2. And then that's how they got to an MBR plant.
So we were kicking this around the other day. My sense was at that time in 2000 and 2001, the regulatory environment was such that there was a high demand for something like an MBR. They weren't just going to take anything, given the TMDL pressure. Am I wrong there?
I think it's first.
Say that the MBR was chosen because it was an exceptional system
That's right.
that would meet what was seen as exceptional demands at the time.
And it would fit on the footprint.
Yeah, I don't know about that.
Yeah,
I would think that would have been a consideration, because if you want to keep that site, you can't put a traditional activated sludge system.
Right, and this is one of the concerns I've had all along is, here we are so many years later. And we're kind of sliding on the original intent of that 2000 to 2008 process.
And what I will say is take it with a grain of salt, but if you look at the GHD report, what they modeled was saying what you're looking at today is artificially low because your flow is so low. So as you grow and your flow continues to go up, when you model that out, you're going to get closer and closer to your permit limit.
Yeah.
So it's not going to stay where it is today and increase your flow by 2.
Mhm.
It's just not going to happen.
No,
And that's
but if you look at that table in GHD report, we've already come pretty darn close to the permit limits at that lower flow rate.
I'd have to go back and look because I can't remember.
You mean on episodically or? not?
I have a side,
Yeah.
not on an average basis. I mean, the maximum was at like, I don't remember what the number was. It might have been 7 milligrams per liter of nitrogen, something like that. That's not at 3.5 NGV, that's at 1 or something like that.
Well, I think what's interesting is when you go through, they even did a comparison on what the power cost would look like. for the facility, which they did a 2 million gallon, 6 million max. So their average daily flow was 2 million gallons and they have a 6 million gallon peak factor. But they put in their power cost estimate for the plant as a comparison. It was like 200 some $1,000 a year. And I know that we're a lot higher than that.
You're talking about the whitefish.
Yeah.
You're right.
Right, and
Yeah, can we get those numbers?
Oh, I sent you the link. You can go on. It's all.
No,
No, for us.
Oh, ours, yeah, I can probably go through and get them.
That would be helpful.
and given some of the things
Can
that we
we-
talked about in
We do the
mitigation,
next meeting.
I think you already have it.
Do we?
December 1st,
Yeah, Friday.
Oh, okay.
3 o'clock. December 1st.
We'll see you, Donna.
Okay.
Okay.
thank you, Donna.
Oh,
Thanks, Don.
Great
Sort
seeing
of
you.
that.
We'll see
Okay,
you on
so
the
you've
first.
got
Happy
a-
Thanksgiving.
Thank you, you too.
Thank you.
Happy Thanksgiving.
Yes.
Yep.
So we're sort of at, we have an idea of a technology that seems like it will work in the footprint or
Yes.
elsewhere. If it were planted elsewhere. What do we do from here relative to the assignment?
I would like to see us have the capacity information and power information
Yeah.
for our existing plant. And look at how we might configure the existing plant. To fit in this technology. So we have something we can present, and then alternatively. For option 2, where we might put that. And whether we would maintain part of the system on the existing site. Like the headworks.
Right.
The sludge management, where we have pipes going back and forth across the street, the things that people would find smelly and objectionable. Could we leave them where they are now and just pop an aqua narita system over there across the canal? I don't know if that's feasible, but that might be a lot more politically acceptable. You just have some big tanks and some a pumping station. Austin, does that make any sense?
So the usage stuff we can pull, the capacity, is that talking about the capacity of the existing tanks?
Yes.
So is that something that you want us to go back to GMB who designed it to get that information?
We don't have that, huh?
It wouldn't be like off the shelf.
Okay,
I don't know if it would be on the as-built drawings or not, because if I can remember correctly, the oxidation ditch is probably 50 years old. It wasn't done in 2008. That was all pre-existing. I may have it on the as-built drawings. I just don't know if it'll show depth.
yeah, right.
but picking up on something you said, is it even feasible? Again, I'm the least qualified to ask any of this, but is it even feasible to do what I think I just heard you say, which is to somehow split the process and have part of it stay on site and part of it get shipped back over the canal to some new facility that would employ the aqua narita? I don't even know if that makes sense.
I don't know if it does either.
Yeah,
That, you know,
I mean,
you're talking about more.
you're still in option 1 and now you've got option
1.5.
1.5 and 2.5. It seems to me like before you split the system, before you move it across the street,
Right,
it'd be it might be worth spending a little money if the board would agree. To say, what could we do here? Aqua Narita is 3. Give us a ballpark on rebuilding this plant here. And you know, I don't know what the number is, but let's say it's $10 million, okay? And then, you know, maybe somebody could say, this can be reused, that can be reused.
Right.
We could pipe it from here to there. You know, ballpark and 15,000 foot level.
I just don't know if they'll do it.
Yeah, so
Well,
They only sell the technology.
I don't think they will.
Yeah.
I was thinking you spend some money with GMB or somebody else.
Consulting engineer.
Yeah,
Some could, you know,
but I don't
or
think the board will approve money at this.
or Mark, you know,
well, how did it, what's the appetite? The other piece of this is you've made several points, Austin, about which have raised in my mind, what's the appetite within the board for changing the management scheme? Who's running the plant? You know, it's been kind of nice to have a contractor. It may very well be that if we were to go down this path, it'd be a lot easier if we had our own staff. Is there appetite for that at the board level? You know, I get the impression, just reading the room, there's a lot of interest in maybe just handing this to the county and paying the bill and being done with it. I may be completely wrong.
I mean, you gotta look at it like from my standpoint and my background. I mean, when I came in to this organization, the first thing I did from an operations level was look at the billing system. The billing system had 9 people touching it, 9 different vendors. And we went from 9 different vendors down to 1. And they do everything down to
and you got
postage.
the envelopes right side up.
Yeah. See, there's a positive. So at the end of the day, you have a plant that you own that you're paying a debt service for, and you have an operations and maintenance contract that obviously costs money.
Mhm.
And it costs, I think the argument even more now is that it would cost more to contract operate than it would to do it yourself. Obviously, there's a burden, but then those employees are your employees. So if you have an issue on the water side, you now have 4 or 5 additional employees that you can call on. So no matter how you look at it,
Do you think there's an appetite actually for taking it back in-house?
My appetite is always to look at it from a financial standpoint of what makes
Yeah.
the most sense.
Well,
And
and you've talked in the mitigation committee meetings about the future costs of electricity.
Mhm.
Even just looking out into what's going on with NRG. I mean, that's, to me, that's been in the back of my mind the whole time I've been reading through this Aqua stuff. Anything that reduces the electrical requirements to deliver a proper sewer quality, it sounds to me is a good thing. Being at the end of the line here.
Or you offset it and you put renewables.
Right,
Okay.
Yeah.
Yeah.
Different thought.
Okay, but it sort of seems like where you're really going is you get a decent number on this. You know, operate here, new technology, it can be done for X and operate for Y. And then you're negotiating with the county, and the county will have some new numbers that they didn't have last year because
right.
they'll have a completely different construct. And you'll negotiate.
This is a refined option 1. It's more informed than what we've had.
Your option 1 is stronger and your option going with the county is different in some way, substantially different.
That's your question?
No,
You're
No.
chopping.
no, I'm gonna hold my fire
Okay.
because I'm not gonna embarrass myself.
Oh, come on.
No,
I've been embarrassing myself all day.
no, no.
But it's
I'm the last person who should be participating.
the whole process of this is brainstorming. What we're doing
Yes.
is brainstorming. It's no different
Right.
than when you look at something that you've done the same way. It's taking
Yes,
the assumption that that's how we always did it
right,
to change that. Right? I mean, that is, you look at the federal government, the state government, the local government, and all the other organizations. It's the notion that that's how we always have done it.
and that
It's
we
when you
always
have to-
need to do it the same going.
Yeah.
Yeah, I mean,
Yeah,
I don't think you'll get by Hans and Preston that Wolfvik needs to have new technology and run different. They die you might have some, yeah, an opening.
And that's, of course, a very typical, with all due respect, of engineers, because it's proven, right?
Well,
And it's
So
tested and it's proven, right?
the
It's what
other
it'll take.
the other option would be is that if we're in a situation within this committee that we feel strongly that there would be a benefit to having somebody put eyes on this, is that do you take that back to the board and say, this is where we're got, and we can't really give you what you want unless we go to the next step, and that
Which is money.
So
And that's gonna cost
so
them
do we
money.
have- do
We
we
know.
have
I mean,
enough- what-
that's kind of where I'm at.
Right, what does it take? What are the requirements to do that? What do we need to prove in order to tickle them enough to elicit that response? And I mean, it seems to me we've got to be able to prove that there's enough value, enough decreased cost or something else to warrant that investment in further analysis.
I mean, you can just sitting here thinking about it, you can look at it from two different lenses. You can look at it from the lens of you either retrofit an existing facility or you look at relocating the facility because the technology allows you to do a much smaller footprint. And so when you looked at the GHD report,
Right.
the one thing was that you have to throw a number on your real estate costs, both
Right.
east and west side,
Right.
plus then you have the ability of putting infrastructure in the right of way, which then you're at the mercy of another state agency.
Yeah,
Luckily, you haven't redone the Gills Neck piece. Right?
That is correct.
And frankly, seems to me, unless there's a real reason to do it,
But the state doesn't
The-
even
the-
need to get involved in that.
the pilot town project. Until all this stuff is worked out, I don't know why you would start any of those other projects.
Talking about,
Like Cedar. Or,
we've already determined that.
oh, okay, so that's all on hold until you figure this.
Well, from a budgeting perspective, it's tough because from a staff level, how do you sit down and you put a 5-year capital budget together? Well, we're trying to work hand in hand with the city on their streets department.
Right.
When you have this $20 million Easter egg, $20+ million Easter egg that's just sitting there.
Okay.
Because that's really what it comes down to. And once you have a position to where this seems feasible, then you can pull every card in the book. You can go to the state. Look, if the state wants the plant moved, as apparently the discussion has had,
Right.
then it's like put your money where your mouth is.
yeah, exactly.
And you go and you start tapping into that. You go to resiliency funds through FEMA. Because if you're gonna relocate, then you're making the argument is why are you relocating? You know, it's either hardened in place or you move. To me, you can hit FEMA dollars pretty quick on that.
Have you engaged with Danielle?
We're engaged with the University of Delaware on actually having this same discussion, but with pump stations. So we submitted for $350,000 for planning for pump stations in the floodplain, which includes taking all the electronics, moving them out of wet wells.
Getting them all, doing the mitigation piece.
Yeah,
Okay.
which it's still, you're still gonna fight the same thing as
Yeah.
if you put the money into pump station 4, if you build pump station 4 the way that it should be built from a flooding perspective,
Mhm.
it's not from the eyes, it's gonna be raised compared to what it is today. Now you can mask that, and I've seen it. You go to Charleston's below grade anyway, like New Orleans. You can get away with it. I mean, you really can.
It wasn't lost on me that you pulled up that Charleston plant.
Yeah, that's literally in the bed.
Yeah.
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 It's, I mean, theoretically, you could go to wastewater treatment plant at the lowest spot.
Yes.
Mhm.
So it's not where it is today it's not atypical for it being located where it is.
No,
It's just a conversation of, is that
So
what
now
you want
what?
it to be?
Yeah.
Because you're kind of at the crossroads of how do you invest, right? You know, Tim makes the argument is that you're putting all this money into the headworks. Well, you better damn well use the headworks for the next X amount of years. And there's a threshold. It's like, okay, if you're looking at 2050 and you want to start implementing, you know, if you want to create a resiliency fund, what are you creating that resiliency fund for? You're creating it for that event that happens, whether it's 2 years down the line, 10 years down the line.
Right.
So as we were talking, if somebody were watching this video, they'd see me looking at my phone. I'm gonna go back and look at an application that I found a while back when we were doing the sea level rise stuff a long time ago. That can tell you, based on all available science, and of course the science is constantly moving. How many times will the water exceed X elevation in the year you specify the year? And so, I'm thinking, well, what does American Legion Road look like? How many hours in a month or a year will there be water on that road in the year 2030, in the year 2035? This directs the decision in a way beyond the level that we've been working with GHD, where you're just saying this elevation. It sort of gives you a sense of what the actual challenge is going to be,
So there,
boats, cars, what's going to happen with everything on the other side of the
the
canal.
insurance company is doing the exact same thing, because there's this new insurance, which I think you've heard me say before, which is parametric, which what they're doing is they're taking data-driven analytics.
Right, the same data.
You're
Yeah, absolutely.
essentially creating policies that are driven by the data that you're talking about, in which you say, like, if you want to cover 10, 15, 20 million dollars, okay, you're going to take out a policy for 20 million. The premium is going to be through the roof, but the way that it works is they fund you very quickly, but it comes at a cost, and it's all based on what you said. Like, if you want gauges on specific buildings, when the water reaches that gauge, you're paid out. Comes at a cost though, and it was new about a year and a half ago, and it's becoming more prevalent because people, it's either you pay to move it or you pay to insure it.
Yeah.
There's more to talk about there, but the city or BPW needs to put more money into real-time monitoring. We're relying on a very sketchy pile of data to tell us what's going on. We're relying on elevation data collected at the Cape May Lewes Ferry dock, and we have nothing to tell us what the water is doing inside, other than anecdotal information.
Well, and it gets into this unique spot, because what parametric does is parametric not only covers you for what you're trying to insure, but it covers you for, in theory, okay, let's just say you have a hurricane that hits the beach side, and that's the worst hit area. And so you start to have this discussion about retreat. Well, how do you maintain and rebuild a facility with revenues that are now lost?
Right.
And so then you get into that whole discussion on how that gets, influenced within the matrix of parametric policy.
Way back when I first started looking at the the Narita technology, they had these things called package plants.
Yeah.
That they were selling over in Europe. And talking to Richard Nichols, one of the board members, Richard said, well, why don't we buy 2 package plants, put one on the beach side and one on the other side? And I said, that's an interesting thought, but so when the beach side disappears, we still have a plant over.
Well, and so really, when I look at that plant, I look at it as, I'm not so much worried about the frequency of the floods. I'm more worried about the one storm
Yes.
that comes through.
Yeah.
Because that's what it'll take. And I don't think it's a question of if, I think it's more of a question of when.
If I noticed you didn't respond to my email about those amphibious
Vehicles. Yeah.
vehicles.
So the city actually had, I think it was in the police department, had a Humvee at one point.
That's right.
If you look at fire departments, so if you go down past Bethany Beach, and if you go to a couple other fire departments, they actually have deuce and a halves that sit there. And those deuce and a halves are specifically used for when you have high flooding, because you can get pretty much anywhere in them things.
Yeah.
Bethany has gone so much further than this area for planning for the future.
Yeah.
It's held up by the university as one of the best examples of taking the bull by the horns. I mean, they've gone to the trouble of investing in a piece of real estate that's in high ground outside of the municipality to serve as an emergency operations center. When
Have they constructed the center?
they have,
Wow.
I think they have.
Well, Bethany does.
Where is it?
It's like inland up 20, up to, 26 or
Yeah.
I don't know where it
That's
is.
my neck of the woods. That's why I.
Yeah.
So the American city will evacuate to that location.
Yeah, really.
I apologize for interrupting the discussion here, guys. I just wanted to say I have to jump off, but thank you very much. And it was really good to see
Bye.
everybody.
Thank you,
Yeah.
Daphne.
All right.
Thank you.
So yeah, I mean, they've had enough problems with sea level rise already with flooding in the low areas of Bethany Beach.
Floods all the time.
Yeah,
Yeah,
and they went through that desktop exercise that the city goes through every couple of years. And they realized they needed to come up with a better program, so they actually started the wheels in motion to build an emergency operations center that was truly high enough that it would function when everything goes out down.
Do you know who created that vision for them? Or was that a matter of commitment that came from the political side in Bethany? Or,
So I know who has the answer to that. Called Danielle. Danielle brought this guy in. He's a young guy. I think he's maybe the deputy mayor. I don't know what his role is now. He's in the city infrastructure, and I don't think he's like Austin's age. Maybe he's a little older, red-haired guy. You may know him. I can't think of his name. I've got his card somewhere. But he made a presentation at a sea level rise planning meeting. Actually, Robin was at the same meeting, heard the same speech.
Was that the one that was just back in August?
No, this was years ago. It was a few years ago, but Robin was in the same room that I was. He was at the time at the city. But anyway, this guy outlined this whole process that involved all these planning steps, but it also involved a real-time monitoring system that they committed to with half a dozen data points around the city where they're collecting real-time information on water levels.
you and I have talked about this before.
Right.
Yeah.
But for this conversation, I think it's more useful to talk about the emergency planning piece that they set in motion.
Right.
But
That's right.
Austin, maybe because I've got just a lot of things going, I would love to hear, it's at your convenience, for you to shoot me more of that parametric stuff you're just talking about, because I forgot it. I think there's a lot of value.
Yeah, it's definitely unique. I mean, like we talked about it originally when we had the conversation, we were talking about, okay, so if you try and do a parametric insurance policy for the entire cost of the wastewater treatment plant, but is that really relevant? Like, are you going to lose the entire wastewater treatment plant if you have an event? So then it is, okay, do you look at covering 50% plus
Right.
30% of revenue?
What happens at this elevation? What happens at that elevation?
And you can tie, so the greatest part is you can tie it to gauges that you put on the buildings.
There you go.
So you can say, okay, once you reach this level, which is at 5 feet, like right where the, right for where it would go into the digester building where the blowers are, that would trigger a payout of $4 million. And you
Right.
could go all the way up to, covering, well.
What kinds of costs are you talking about?
From when we were having the discussion, it was. I think they said it was like 4%. Your premium was 4%.
Of your gross?
So this was a conversation you were having with an insurer to.
Actually, our broker, our insurance broker, because they knew about it, but they didn't get involved in it. And this all started because we went down to, Tim and I went to a conference.
4% of $4 million is not even sick.
Yeah, that's because we were talking about like $18 million because we were like 50% here and 30% there. But then you look at it, it's like, okay, for us, does that make sense to pay that out for nothing? I mean, it's just, it's the the assurance of having that.
So it's taking, the way I look at this, based on the way you described it, it's taking the kinds of thresholds that are in one of those tables in the GHD report and saying, at water level of 5 feet, here are the things that happen, here are the things that go down, here's what it costs to get them up and running again.
Mhm.
You know, at 6 feet, it's this, at 7 feet, it's that. And those things actually do make some
Yeah,
sense.
I think you can do it, but basically
So
what
instead
the
of
finance
self-insured,
guys are doing is it's a game.
Because
It's a
our
raffle.
policy is
Uh,
self-insured
you
for
know,
pollution, but
how much,
we
what's
might
the
adopt,
chance that
pollution
you're gonna
insurance
lose
because the pollution insurance
$10 million?
was like
Well,
14,000 for 3 years. Why not self-insured?
they'll
Million
play with you
dollars
for
if you
$4
get a
million,
policy
$400,000
sub
a year.
$400,000.
Right.
That was
You know,
before
it's a
they-
life insurance.
But flood insurance is
Yeah.
just.
It's not,
astronomical
you know,
high.
you're not gonna
So
argue
then
that the
question
plant
was,
got
okay,
hit.
if flood
You're not
insurance is
gonna
that
argue
high,
that the.
Or if you had all the data in there,
that
that says the water got to this level, then we gotta do this.
You show up
And
with the
then
death certificate,
Yeah,
and
they'll pay.
they pulled in
Yeah.
people that had experience with Department of Homeland Security,
yeah.
all kinds.
Meanwhile-
We actually talked to the broker that writes the
you
policies,
know,
but we sat
I'm
down
just-
and
We spent a lot of time in these
hour
years
and a half,
yeah.
some of
went
us
through
talking about,
how you structure it.
not if, but
I mean,
when
we even said
things
that
are
the list
shutting down on the
all
other side
pump
because of
stations that
flood
we would
levels.
insure all
I
our
get home
assets
and
that
my
we would
dog's
insure,
ill.
so that we
But-
could get a benchmark, because the issue is just like Sumner said,
So
they wanna
next
use,
meeting,
they
I
wanna
think
use the tidal gates
we'll
from
talk about
how
the
the,
whitefish.
Fair,
Yes.
yeah,
but they give you a
And
discount
I'll
if you're
see
using
if I'll,
relative.
what
plus,
information
yeah,
Austin
yeah,
can get
where your
about
assets are actually located.
And then you
existing
mentioned it would be
capacities,
Anybody that
at the
would want
plant.
to.
Well, and you're saying
partner in
existing
putting the-
expenses.
It's like, oh,
the
wow,
operating-
relationship
And
that's the state.
existing,
Like
yes.
what it costs
Yeah,
and.
I don't
deducted
understand why
electricity and
those
stuff.
kinds of,
Yeah.
metering
Yeah.
stations
I would
have
also
not
And
been done.
chemicals and.
I mean, that's, it
Uh,
can't be
yeah.
that expensive,
Right, so.
Those operating things.
is it?
Yeah.
But I
don't
would
think so.
also think it's sensible to say,
It's about the.
okay, GMW.
And
We have
committing to,
25,000, we
the-
pretend to have
This is not
$25,000.
It's the excuse of, this is how we
To
always.
flesh
do it.
this
I know it's that,
Um,
You're still live.
Yeah, no, I was gonna say. Do we
Are
wanna
we?
end?
Yeah, we on end.
yeah, let's,
Motion to end, second, third, fourth.
Okay.
All
All
Oh,
in favor.
was that all being captured?
You gotta do, yeah.
Oh, great.
Yes.
no, no,
Aye.
You were.
Well, we have a quorum, so it had
Yeah.
to be.
Well, and I don't vote.